Okay, nobody's watching, or at least, okay, one person's watching. Anyway, hello everyone. So, today I'm going to go back into this project because last time I left it in this weird state, I think. I just remembered that I gave up after streaming for many hours, and halfway the code I was producing was just very, very bad. And this doesn't really work at all as expected. And I did make a list of things that I want to improve this time. But in short, the idea is that I want after this stream the code to be in a decent shape that anybody can do modifications or improvements to it. Now, I do have here some notes of how to make the code better and also how to fix the bugs that are there, and we're gonna look through them a little bit in the beginning. I also have gotten feedback from people. So if you look in this video's description, I've added there different versions of these Strandbeest simulations that other people have made. So Peter and Explore Infinity on Discord have shared some things. So if you look for these topics, you will find them talking stuff about it and sharing also their repositories. And we will look into those as well because I'm going to steal some of Peter's code at least to make our code base a little bit better. And Peter also pointed out somebody else's repository, this person right here. So I listed this one in the links as well. It's a MATLAB code, and it has to do with optimizing the Strandbeests. If you remember, my hope was that I could simulate this experiment that Mr. Jansen has made, and this video from Veritasium was talking about a little bit of figuring out what is the best path here at the bottom that the leg would create. So we would have to optimize the length of these different sticks so that this bottom shape is as good as possible. And what I would really like to do eventually is not focus on one leg in particular, like what is happening in this video. But actually, I would like to make the beast work at some point, and then I would like to have it move with some leg properties and change the properties and have it move again. And the whole beast movement I would like to optimize because the idea of generating this shape at the bottom, I tried to simulate it last time and I tried to calculate some properties, and in this MATLAB code, if you look there, there are some statistical measures for how to get it to look kind of triangular-y. But this triangular idea for it to have that path is, I think it's a little bit arbitrary. So I would like to see, uh, can we figure out a path for the leg to create that actually moves the beast better? Anyway, let's see what will happen. But first things first, we have to go back into this code base, and I don't remember it anymore. I just remember many messy things. So I'll play with it a little bit and clean up. So this process of cleaning up, based on also these notes from somewhere here, is going to mean that I will reintroduce the project to me and also to you. And eventually, when the code is as I want it to be, I will do one summary in this video. Maybe I'll add a uh, timestamp for it in the description so you can click to that summary. So if you ever want to take this project and proceed from it, I think that hopefully good quality code base is something that you can start building with. Hello, Amer. Yeah, so that's kind of it, I think. This is the idea for what happens today. And let's look at the code base. So I have it here open now. And I also have open Peter and Explore Infinity's versions here in this other VS Code window. So I colored it as red because at some point we might look into it as well. So what I have from last time is this thing right here that collapses. I don't know, the physics is not quite right. The friction at the bottom doesn't work as expected. The forces somehow look like it's moving a little bit on a frictionless surface. So it's kind of bad. I also remember that I had this possibility to simulate, so optimize the leg shape somehow. And maybe it works if I change this function call here, but let's see. Yeah, so here it was generating many different legs and then scoring somehow the path that they are creating. The green was better, supposedly, according to that scoring criteria, something that wasn't very well established. But maybe I can look into this one if we end up to that point again. So this is like this genetic algorithm for optimization thing, but also this other way of calling the project is just creating the beast as a whole. And this is trying to attach two similar legs, mirrored legs. It's not going to work because it needs more legs. I know that. But looking at this simulation, it's obviously wrong because two legs wouldn't slide like that and the friction is not there. And the code we used to create this is a horrible mess. We'll get to that. Now, Peter's version from his GitHub is, let me see, do I have them? Yeah, I have them here. Both of them. So Peter's version looks like this. It's great. It looks fantastic. But if I remember right, and I don't know if he did some updates meanwhile, but I checked his initial code when he submitted this. If I remember right, there wasn't a friction there. He did essentially trigonometry and figured out where each of those points has to be. And then he implemented this motor thing in the middle, similar to what I tried to do, and calculated the coordinates of all the points. So no physics or anything like that. And then this animation moving from the left to the right is actually kind of artificial, like the creature is not supporting itself. It's just being moved horizontally with the fixed rate. And you can kind of tell a little bit that like these points here at the bottom, when they touch, they slide a little bit. So it's a little bit artificial, but of course the end result looks fantastic. And what Peter has in his code is this calculation of where each of the points has to be in the initial state of the legs. And that's something that I had a very kind of this way solution last time. So I did something lazy and I tried to not focus too much about where those points are, but let some algorithm optimize it for us. And I don't like it. So it's overcomplicated, and it's a source for bugs. Maybe there are some bugs there. So in Peter's code, at some point, he's using those numbers, so-called holy numbers, that we got from this video here. And with that, the leg points are calculated with trigonometry. So I'm going to steal this part, most likely. And Explore Infinity, he had some interesting things to talk about in the Discord. The result looks very similar to Peter's. He has two of these motors here, so essentially making this platform a little bit longer. Now, this beast is not being animated to move around, but it does seem to be very similar to what Peter has made. What he was talking about was very interesting, that these motors that we are using to move the creature, I mean, they are kind of, if you've watched this Veritasim video, it's very interesting because Adam Savage is also there from Mythbusters, and he has created this version of the beast out of metal, and he is powering it by pedals. So it's kind of like a bicycle with these with this skeleton thing in the front. And okay, he's on this that box with the wheels there, so it kind of works. But this motor is not something that the creatures on the beach have, so they are pushed by the wind. And Explore Infinity was asking, is that motor something we can replace? Because it shouldn't be there. It should be the wind, so some kind of external force that pushes the creature, and then it starts to walk. That's like what the things do on the beach in the reality. Okay, Simpsons reference. Seems to these things have also made it into the Simpsons, so you know it's a very cool thing. So yeah, they are moving on the beach because of the wind pushing them. So that motor I would like to eventually turn off, or not make it move the beast, but something else. So all of these ideas, somehow eventually I want to get into this. And now, having seen these different ideas and these other code bases, I'm going to keep just this tab open, because maybe we will need to look at the statistics here a little bit at some point, so I don't want to lose it. But otherwise, I have my version open now. And what will happen next is me trying to figure out again what the code is doing and simplify stupid things about it. And these ideas from here. So, okay, the function scoring the path. So this is something that we might get inspired by this person right here, Rongu, if I'm pronouncing it right. Then the leg should not have a motor. So I think my implementation now is kind of crazy. Each leg has its own motor there, rotating it. That shouldn't be the case. There should be one, and then the legs should attach to that one. And we don't even have an object for this Strandbeest, so the function generating the beast here, it's just floating particles and sticks in the air. And the legs, I don't really know what's happening here. Flipped leg, there's no way to really flip it on, like maybe it could be a helper of the leg class or whatever. We'll figure that out. But there's no beast object, So we have a leg object here, but not the beast object, and that's a problem. So I think that it will simplify the code a lot if we have that. And the idea is that the beast has many legs, and each of the legs gives you some kind of endpoint that you can use to connect to its motor, to the one and only motor. That's kind of the idea here. Yeah, some crazy stuff happening here as a result. So because we have, yeah, I don't know, some messy stuff that I hope just goes away. And then the physics needs some friction. The idea I was writing here is that you try to move the beast without the friction, and then you see which point touches the ground before and after. And if the points are touching the ground even after the movement, then that means it's not trying to get off the ground. So we mark them as static and revert to the previous position. So somehow looking in the future, checking if the connection is still there, and if it is, then revert before it moves, and that would be an attempt to implement friction. Okay, hello, Javer and Hibran. Okay, Mexico. I guess it's much more warm there than here. I was just ice swimming in the frozen lake. So I came now from swimming because these live streams, I somehow try to have more energy during them, and that thing gets your energy levels high. Right. So, let's see this code. It has here some global gravity value. Maybe this could be somewhere in the physics class, like another file that we could implement this logic, so we don't complicate too much this this main file here. And then this generate beast is something that we will replace. So let's create here a new file. Let's call it Strandbeest.js. So here we will have some kind of code, and it will be similar to this leg class in structure, I think. But this leg will also update a little bit, and the Strandbeest will be made out of multiple legs somehow. So that would be the overall idea. Now let's see a little bit how this leg looks like. So the constructor has an XY position. So this is the origin of the leg. Okay, and then this generate the leg function with the origin vector and these given parameters, A, B, C, D, the so-called holy numbers. And I also have a parameter here for is flipped, apparently. So that's how we were flipping the leg for the Strandbeest object that we were creating with this messy function from there. Okay, and generate leg, this function. So it creates the particles, and then it creates the sticks between the particles. And it also creates a motor. So this is something that needs to be different because we don't have a motor for each leg. The motor is for the Strandbeest, and it's maybe eventually gonna be just a rotating thing there without the power to move it. But for now, I think we will keep it as a moving part that will transport the creature around. Okay, so that's one thing. this generate leg. And then score path is something that we will look at much later. So when we start to optimize these beasts. But where are these A, B, C, D values coming from? So let's see. In the first one, okay, I have the values from the video, and I think these were the values from from my genetic algorithm. So the thing that I tried to optimize there, but they weren't very good. And these were the ones from the video. So the leg was generated with those specific values from the videos somehow. So these ABCD values are from there, but here, okay, so the first particle is going to be at this origin vector, and true, I think, means that it's a static particle, so it's not supposed to move. Yeah, so some of these don't move if you think about this animation here. This one and this one, they are static as an individual point, and this red one here is also static. There were some discussions last time that maybe we don't need this point and that it's somehow coming as a result of the other two. Yeah, but let's not worry about that too much here. So this value for each particle, these coordinates like 0, 0, -50, something, something, these I think were a crazy invention to make the particles go towards the proper location. Let's see, there is here this generate leg function, so we are not creating, we are not creating the leg directly there. We rely on this function that also does this calibrate. Oh boy. So this calibrate, it's a method inside of the leg class. This one, and it was doing very weird things. Yeah, nobody wants to work with something like this. So somehow updating multiple times in a while loop and crazy stuff. So I don't want this function anymore, basically. This calibrate function has to go away. Very complicated stuff happening here. The leg should be created as you expect from these specific values. So I don't want this anymore. I just want it to disappear because Peter showed us a way that you can calculate the legs, each of the coordinates based on those lengths. So knowing the values for A, B, C, D, and so on, and the starting location, you can somehow do clever math and figure out these perfectly, not relying on some weird calibration mechanism that is very confusing and a source of errors and many other things. So I dare to just delete. We don't have to think about that anymore. And every time we would call this calibrate function, we just remove it. And that means that this generate leg function is probably not needed anymore either. So okay, so I'm looking for the whole word here, generate leg, generate leg, generate leg, generate leg. And then here there's one of these private methods, and this is the one where we will use Peter's code. I'm quite confident about that. And we only need this one because the sticks are gonna happen between these particles here. But we need them to go to the proper location. So here they weren't going to the proper location. I just made them close enough. And then that calibration was stretching those sticks, which shouldn't be stretchy. Crazy stuff. I remember I was kind of playing with ideas and overcomplicating this way too much. So every time we have generate leg as this function from the main class, we can replace this one with just that, basically. So leg calibrate doesn't exist anymore. So that means that this generate leg can be new leg, and these are going to be now the parameters. So this one here as well. And I don't know if this code is going to be useful, but I want to make sure that when I do these changes, I don't destroy everything. So let's now figure out where, okay, generate random leg was also there, new leg, so on. And this generate leg method, we don't have to change that, but let's have a quick look. This calibrate is not used anymore either. So now the code should work, I think, but probably the sizes of the beast will change because it's not doing that initial calibration thing. Let's just see what happens. Okay, some weird blinking with different colors every time I refresh, and that's it looks pretty similar as before, but behaves a little bit differently. And those green lines that I had previously are gone. I think that was as a result of the calibration. I think that the initial coordinates for that beast were very close to the true ones, so I don't really see a significant difference here anymore. And maybe the calibration still happens as this as the segments that are wrong, a little bit wrong, are going back to their original location. So these color coding, there was some coloring visual emphasis of how, like a visual depiction of how each segment goes to its true desired length. Let's see if we replace this code with this one from here, so that instead of using the numbers from that video, we use some other numbers, basically almost random, because we didn't do a good job at optimizing. So again, a little bit of this calibration happening in the beginning, because it didn't happen in that while loop that we removed, that crazy stuff that was happening before. So this calibration that you see here and those weird colors emphasized there are gonna go away if we do a good job at figuring out the initial point locations. So I just returned to the ones from the video. This was just a quick test. even though this one actually moves a little bit. So my values are better for this bad physics that we have here. Eriko, okay. I mean, I think the main part of this video is trying to understand the refactoring idea, that the code now is a mess and we need to clean it up, not continuing in the messy way. But then at the end of the video or somewhere in the middle, I'll do a brief explainer of the code after it's been cleaned up a bit. So that's the point that will be most important, I think. And yeah, okay, other people as well. So I can't pronounce, or maybe Prajan, Pragyan. I don't know how to pronounce that. And Fatih, hello. So yeah, let's see. Can we get rid of this calibration issue? So the points are not going at the correct location, and I think that we can see the code inside of this stick class that is doing those colors. So there is a way to calculate error for each of the segment, and then here I was interpolating between yellow maybe and red hue, and then depending on the error, and I scaled this error because the error was not significant enough to show in any way. So now maybe the error is actually quite significant, and that's why it's showing like that. But eventually everything seems to stabilize in this close to red state. So this segment here is it's more red than this other one that is appearing more orange. And that's because this segment is really as true as it needs to be. But when all forces are applied on this creature, some segments will be stretched just a little bit, and that's why they turn a little bit orange there. If we would multiply this by even a larger number, I think that, yeah, now you see the beast in different colors. So now this yellow is closer to the red. Let's remove one of the 0. Okay, I kind of liked the previous version, but this error is very, very small now. I had to multiply it like this just to be able to show that it's really it's really not perfect, but yeah. So okay, so when the error is 0, it's going to be orange color and then moves towards red color. But if the error is really big, then this goes back towards the other colors. So minus values here, so the hues wrap around the circle, and that's why we see other values when we scale the error a lot. So they, yeah. So this 30 is the orange, and it's going towards 0, which is this red. But if the error is very big, then it's extrapolating after this one. So that's why we see other colors appearing there. So this scaling of the error here is a little bit fidgety how I'm illustrating this. But I hope you get the point. And this initial situation, so this initial blinking in all kind of colors means that the segments initially are very far away from their expected length. So from these numbers here. And that's the thing that I want to calculate precisely using I guess, this code from Peter. So this calculate leg function here. And I'm going to take it, this whole function from here, and study it as I'm trying to calculate the coordinates for these particles here. So we do have already the generate leg method. So this calculate leg, I'm just going to rename it to Peter's leg. And eventually, maybe not call it this, but for now, just to have a reference there. And this DNA is something that I suspect Peter uses. Yeah, it's either the holy numbers, or maybe he also attempted something with his own genetic algorithm. I'm not sure, but I suspect that's the thing. So you might pass some other numbers to this constructor, and his creature will be updated as expected. So these numbers are coming from his object there, but in our case, we have them already like this. And P0 is the fixed point. So in my case, this origin vector is P0 basically. First, I want to modify this function by doing as minimal changes to it, but just make sure that it works. So all these values are part of the parameters of the function, and P0 here is this fixed point basically. So I replace it with this origin vector. And now P0 lock, I'm not exactly sure what that is, but I suspect it's the is static idea that that I used in my code there. And here the other points are being calculated, and sticks are also being assigned to them. Okay, so this is going to be a little bit more work, because I think that our objects here don't match precisely, and also the vector classes might not match exactly. So two things we have to somehow, yeah, it looks like I have to modify this function because it won't work as such. We don't have things like lock here. Yeah, so lock appears 1, 2, 3, 4 times apparently in this whole function, and in ours here we had true, 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 true. So I'm quite sure that the lock means the is static from our thing there. Now, really, I think I don't want to modify Peter's function to generate the sticks. I mean, I don't want to make this function that generates the particles and the sticks in our form, but I wanted to give us the perfect coordinates that we can use in here based on these. So I remove from here this type of object and just keep these vectors for P0, and it doesn't matter. This function will only output coordinates. It doesn't lock anything. It doesn't create sticks. It has the only responsibility of generate coordinates from given lengths. Okay. Hi, Shri. I'm working on this Strandbeest simulation stuff that doesn't work at all, and I want to get the code base in a way that others can work on it as well. And hello, Abdul. Okay. Now P0, I don't need to change anything. It can be the origin vector. And we could store them into something like this, or just use different variables for it. Maybe, yeah. I also noticed Peter has here this image of the leg. So this is very clear about what is P0, what is P1, P3, P4, and so on. So let's keep this one open as well. And so P0 is this origin. I wonder if this is the same origin that I had. Let's look a little bit here, because I'm worried somehow maybe I used P1 as the origin and that will mess things up. So A is between P1 and P4 in my case. Yeah. I have them labeled differently. Horrible. B is between P3 and P4. Yeah, this is not gonna be great. So the way I probably named my points is different than the ones here, but I think the letters here are as I had, because I was looking at this this animation from the video. So A, B, C, D, A, B, C, D. These are same configuration. L, M, J, E, L, M. Yeah. A little hard to see here, but L, M, J, E seems to be fine. F, C, K, F, C, K, and G, H, I. These are correct. So they match very likely the ones that I have, but these ways of defining the sticks, I think I will need to update so that our particles match Peter's selection. It's easier to do that, so making it match Peter's naming here. These are, I defined them in some way and Peter defined them in some way. They are not from the original video. This one didn't have specific numbering for the particles, so I choose to move to Peter's way of doing things. So P0, we already have it. That's fine. And it's this one right here, and it should be locked, I think. So this one should be locked. Then P1, I don't want to cast to any new points. So subtract from P0 this vector. Yeah, this L vector, it's right above it. So that kind of makes sense. Let's see here. How did we do vector operations? I don't remember. What is our... Okay, we have a vector class with sub, add, scale, mag, and norm. And Peter has a vector class with add, subtract, magnitude, normalize, normalize, scale, rotate, and dist. So it doesn't match, but it's fine. So we have everything here except for rotate and this distance function. So I'm going to copy them. So rotate with the theta. But yeah, probably we will need this at some point. And this distance function, we might have it somewhere else. We have it here in the utils file, so not part of the vector, and I think we can keep it that way. So I only took this rotate function from here. And I took it because I think it's going to be needed when calculating the leg somewhere. So I see some angles here. Yeah, so there is some call of the rotate function there. Okay. So P0 location. I think that our vectors had this x and y. They don't have a location component. So P0 subtract, our function is called sub, new vector 0 and L. So something like this, I believe, should be fine. And then we can remove this part. So P1 is also locked. I'm gonna put here some comments just to remember which ones are locked in Peter's version. And then this P2, I don't want to do new point. I don't want to use the location. I want to add new vector this direction. So this is something different. So this A, calculating P2, this direction times minus A. So I believe this means if the leg is going to be flipped or not. So let's call this direction here and try to remember that it might be that. It's very likely that he has a solution for flipping. And locked. I don't want to add points or the sticks or anything like that. And then here P3, no location, add new vector, rotate this rotation. Now this rotation we don't have something like that, but we do have a motor somewhere. Motor angle. So yeah, let's put here also another parameter, rotation, and this motor angle has to do with that. So we have to make sure that that part of the code is going to be proper. Many things that we need to consider when refactoring this. And P3 is also locked, and I don't worry about those other things. Now theta 1, angle P2 to P3. So this one there, no, this here, because I have it as a parameter there. Direction is also a parameter. M is a given value. Everything else looks fine. P4, dist. So dist is one of our utility functions there. It's not part of the vector. And location is not something that I need. Imaginary line between P2 and P3. I'm gonna leave Peter's comments. I don't go too much into how he solved this trigonometry. You can check the comments for the explanations. But the reason I don't look into it carefully is because his Strandbeest looks good. So I believe they are correct. And with the angles calculated, new point, new vector, I don't need the new point. I just take the new vector. I don't need location. I don't need this for direction. So I'm making his code work with the variables that are given in a little bit different way. And then P5, no need for this point. I just want the vector. No need for location. Direction is the parameter. Everything looks good now. Remove this part. And P6, new point goes away. Vector without location. Direction without the this. And then this can go away. And then dist between P5 and P6. I don't want to call it from vector. Okay, imaginary line there, but these are all known values. Okay, I don't need that. Subtract in our code, it's called sub. Location, not important. Normalize, we have norm. So that's the difference. And then here, not using new point, we just add, rotate, the new function that we used. Direction is the parameter. And then scale by f, we have scale as well. So this will work. Now this part we don't need. Theta 8, arc cosine, good. Location not needed. Subtract is sub. Location goes away. Normalize is norm. No need to cast a new point. Location goes away. Add is there. Rotate is there. Direction without this. Theta and scale. Good. So we simplified Peter's function, and I prefer it simpler. We removed many things from there. So it generates the coordinates where the particles and the sticks should be placed. We removed some of the responsibility of this function. It's not creating the particles and the sticks. It's just figuring out the coordinates of the points or vectors, because this is we are using vectors, and sometimes we have the polar coordinates, and that's why we have rotation and so on. Now these can also go away from there, and I only use this for the initial coordinates. So let's call this Peter's leg coordinates. And call it here Peter's leg coordinate. Yeah. X scalar, this is what we have as the direction. So we call here origin vector. Okay, and X scalar is definitely looking very much like the direction here. And sorry, this rotation is, I don't know what is the initial angle of the motor. we can look a little bit. So the angle, okay, minus pi divided by 2. Let's just try it. Like that. And maybe pass this rotation to the motor as well, and update this motor's rotation to be this one. And I don't think we have new motor anywhere else in this, so this should work. And now this should give me the coordinates. So if I return them, which I don't, so I should return everything here, return, and P0 is the origin vector. I think I will just return an array and have that. So P, I use P here because in this diagram P is used for these points, and normally I don't use one-letter variables like this, but this one is clear with that diagram supporting it. And then here, the new particles. So we have from 0 to 8, 0, 1, 2, 3, 4, 5, 6, 7, 8. And the particle comes from P of 0. Actually, no need to do any calculations. So all the calculations have been done already. And that means I just type here new particle P1, P2, P3, P4, and this is true for making them static. So 0 is locked, 1, 2, and 3 are locked. So 4 is not going to be static like that. And I don't need this anymore. Some weird comments explaining what those things were, but now this index here is explaining everything that needs to be done. So this should kind of work. The thing we are still supposed to do is make sure that here we are creating the sticks as described in this diagram. So P0, P1 has to be connected with the stick of length L. L is, oh, okay, is correct. So it is P0, P1, or in this case, particle 0, particle 1. This is L. All right. So let's go in order from A to whatever final letter is here, because I need some way to order this and make sure I don't skip any of them. So I start with A. Has to be between P0 and P2. So A is P0 and P2. So whatever I had previously, I will change it to look like this. B is P2 and P4. P2 and P4. C is P2 and P6. D, P2 and P5. E, P4 and P5. F, P5 and P7. G, P6, P7. Okay. H, P7, P8. It's correct, but I change it to P7, P8, reversing it, because I like to keep this consistent, lower first, higher second. So that was H, I, P6, P8. J, P3, P4. K, P3, P6. Then L, I think, was correct. P0, P1. And M, P0, P... No, M is P1, P3 now. So my P1 was P0 before or something like that, and maybe some other changes, but I don't care anymore. So now this is the diagram we're going with. P1, P3. And if no errors, rotation is not passed here. If no errors, then this code should work. But it's not gonna work. I'm sure that I did some errors here, but let's see. Refresh. Peter's leg coordinates is not a function. Okay. Why? Ah, it's a private method, so I forgot this hashtag. Oh, wow. It's amazing. Oh, I got the message from Peter, so I really hope he's not. I guess he's gonna watch this, but he missed this part. Okay, so something doesn't look good, but you see I suspect the rotation, zero rotation, should be something else now. I mean, this rotation that we are putting here, math pi divided by 2, I suspect that in Peter's code it was supposed to be 0 or something. I don't know. Yeah, so the current rotation of the motor is 0. Let's try changing to that and refreshing this. It looks almost correct, but I think that my messy code when attaching to the motor did something, because one leg, because this P0, P1 points have changed. So I'm not gonna worry about that yet. I think that gets cleaned up when we do the motor connection, and the motor shouldn't be here. So the motor shouldn't be in the leg at all. And that means that we can remove it from here like that. And in the update, anything to do with motor is bad. So I don't want to move the motor. These particles can update somehow. Is there anything else with motor here? So update. Okay, something for scoring the path. So if the angle was something, the score is back to null. I think that some crazy stuff. No. If the angle is less than that and the score is no score path, but this score path, it shouldn't be the responsibility of the leg. It should be the responsibility of something else. And I just comment it out for now, so it's very messy. And now there isn't a motor there. So why is this rotating? I don't understand. There is no motor there. This force should be gravity or something. There might be some tension here between the points. So yeah, the weird function in the main class, in the main file here with the generate beast, this was doing very crazy messy stuff. Flipped leg is here, legs push, changing particles to static or whatever, setting the motor to be the same motor, basically when reference was going away, crazy messy stuff. And then the particles, replacing them, remaking the sticks, very messy stuff. I don't like it at all. We won't need this anymore. So I remove that. The beast has one leg and the other flipped leg. It's not going to connect to anything. The legs won't be connected at all at the moment. But it's my way of getting to relearn what this is doing. And no motor, no any kind of messy stuff. But these legs are just independent things created by one function at the same center location. Restart. It's perfect. So every time I refresh this, you see that those colors are disappearing now. So it's not showing anymore that calibration stage, because I think that these coordinates are just perfectly calculated with this new method. We can test this a little bit. If I go to if I make a small change here, so let's say, according to Peter's drawing here, let's say I'm going to move P3 a little bit. It's going to be minus M plus 1, something like that. And then I refresh this. You see? It blinks again there, because the system that generates the sticks, it generates something there with the length 1, with the length M. It should have length M. So in the update method, it's going to try to gravitate towards length M. But the initial location of P3 is now not proper, not correct. So immediately when there is a mistake there in the initial coordinate calculation, you see that calibration messy stuff from earlier is starting to happen. Okay. It looks like we are standing still almost, like nothing is progressing, but it's going just as it should be. The code is becoming clearer. So now that I know that this is generating coordinates, I will rename it. So let's rename it properly like this: generate coordinates from given lengths. Given lengths implies that it's in the initialization process, and it should work well also with these other ones. Let's see. So some weird coordinates I found last time. Yeah, so it looks just fantastic there. The motor is not there, it's not moving at all, but that comes next. So what I want this code to do now, this generate beast, I want to take it as its own function. And I want to be able to attach the legs to the motor inside its own class. So this empty class here is going to be where the magic happens. So like that, and then the constructor. Let's see. The center of the canvas goes there. So I would like the beast to be something like here, actually. So let's take out the center like so. And then new Strandbeest, and then the center location X and Y. I need also these A, B, C, D, and so on. Rotation and whatever I just can consider 0 by default, so I don't need to specify that. And then the legs could be Strandbeest legs if I really need the legs, but I don't think I will need those legs as such eventually. But again, now I want to replace this generate beast function with something better. So let's just make everything work first and then clean up even more. So the Strandbeest object has a center X and Y. Maybe we can just put center as a point there, or as a vector, since everything is kind of I think we can put here origin vector like so, and have it directly defined as a vector here. So new vector, it simplifies some things because we don't need to consider that first we have this weird object with xy, which is not a vector for some reason, but now we can call this origin vector because it's not the center of anything, it has some weird offset there. So origin vector like that, and the leg updated to use this origin vector like so. X and Y are not used anymore as such. Mutate here, okay. So this new leg, these we will replace. It's not going to be a function anymore. New leg, XY, generate random leg. So here I need origin vector, new vector of XY, and let's pass it like so. And new leg, mutate. So we take origin vector up here and pass it here. And the mutate function will have origin vector here, and x and y go away from here. So in this way, we have consistency there. We shouldn't have the problem anymore. And yeah, back to replacing this generate_beast function. So back in the Strandbeest class, we have constructor, and what it gets here is origin vector, and those AB blah 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 holy numbers. Right. And with these, I'm going to destroy this function generate_beast that we don't need anymore. But before that, I copy whatever we have here because it's probably somewhat useful. And inside of Strandbeest, I paste this. And now we have leg and flipped leg. Origin vector here, origin vector here. These same messy things everywhere. Let's see if we can figure out how to clean up that part at some point. And then the legs here, I need a reference for it. So this legs is gonna push that one and that one. And I don't need to return anything because this is a constructor. But well, that's it. So we are taking the legs out like that. So now I think the code should work if no errors. Strandbeest not defined because I didn't include it there, but maybe I make this capital here as well. So let's make this object like that. Rename also this with the camel case. I tend to use that naming convention, so it makes things easier to work with when you are consistent naming things. And now everything is fine. So we can start to work here adding the nicer functionality to add the motor and connect these legs to the motor. So this is the next step. What will happen? So this motor is equal to new motor, origin vector leg sticks p1. No, I don't like this idea. Leg sticks of 0 p1, it's very messy. We don't need to know that the leg has sticks and p1. The leg, according to the comment, to the notes that I had here, it should provide endpoints to attach to a motor. Now in Peter's diagram, I think that p1 is the center of the motor, maybe. Let's watch a little bit this video here. So yeah, center of the motor is there, and then this P3 is moving. So P1, P3. P1 is the center of the motor, and P3 is the thing that would be moved by the motor. So here, origin tip. This works with particle objects. And rotation, we will need to offset things a little bit. and that's gonna be fine, I think. But let's see. So I need to get P1 and P3, and they should have some kind of names. So these endpoints, P1 and P3. So P1 is the thing that attaches the center of the motor, and P3 is moving. I don't know how those are called, which is unfortunate. But let's go here and say in the leg class, get endpoints. So the endpoints is going to be return these particles. Let's just use an array, or origin these particles of 1 actually, and not location. I want to use the thing, and then particle P3. So this is that tip, particles of 3. And this get endpoints, we go back here, we say get endpoints, and flipped leg get endpoints. Now leg and flipped leg, I think let's remove this code a little bit, all of it, refresh, because I don't remember if this is okay. It's the left leg. So working towards a very good code base, let's say here this leg becomes left leg, this flipped leg becomes right leg, and now left leg endpoints and right leg endpoints. That's better. And now the motor, let's connect it just to one leg first. So the left leg, for example. And let's not even push the right leg because it's making some confusion there. So the beast only has one leg, but let's try to connect it to the motor. And we don't need these other two parameters there. So left leg endpoints, origin endpoints tip, and nothing there because this rotation, I guess, should be important because some legs will start at an offset. So let's go here and pass the rotation to be 0. Something like this. Okay, and now if I refresh, the motor is there, but the beast is not updating in any way. So let's create an update function for it. Motor update. I think the motor update should be the first, and then the legs update according to what the motor says. Let's see. The function we created, it's not called anywhere. So if we go back to main and look in the animate function, I think that's where the magic should happen. So this works with each with the legs object. This is something kind of messy. And Scores. The legs don't have a motor, so this is a big problem because we can't move them if that's all we get there. So really this Strandbeest is what we need to work with inside of the animate function. And the Strandbeest should update with the gravity and on the canvas. So does it do that? No. Force and canvas, and the leg update force, canvas, and then score path for whatever reason. I think this scoring of the path will go into some statistics function or whatever. But clean up. So force and canvas, and these are the things that we pass to the update of the leg like that. The motor could have a force as well, because gravity acts on it, but we worry about that later. Now back to the main. So Strandbeest update, this should work, and that means that this is no longer needed. I commented out, but it will be removed soon. Now for the scores, I guess we score each leg independently. This is something for that genetic algorithm that maybe we will still use. I keep it here just for consistency. So legs is still a global variable, but eventually I want this to be a better code and maybe two different web pages, one for the optimization and one for the beast. So clean up and separate this responsibility. Scores and paths and all kind of crazy stuff. This should work. So this is not needed. The legs do move now because the Strandbeest has reference to that. Restart. Yeah. Looking good. Looking very good, I think. The zero angle for the motor is not the same thing as what Peter thinks it should be. He thinks the zero should be like that. But I don't know. If any of it matters. Let's do that because this diagram seems to be like that, and this diagram matches that diagram, so this is very a nice thing that he did. So I'm going to also put here this diagram. Let's also reorganize this code a little bit. So let's put the JavaScript files inside of the JavaScript folder. Because this license and README stuff bothers me. So now the JavaScript is next to each other, and these are something we can ignore. The diagram, I guess it can be there for now. Let's see if eventually we'll need some images or something, but yeah. Okay, so in index.html, let's also update these references because they are coming now from some other place. And refresh this, not the video. This one. Okay, everything still works. Let's make the motor zero angle be the one at the top. So the angle is the rotation. The rotation of zero should mean at the top. Zero is that by default. That means we need an angle offset. So now it starts at the top. And essentially, when you pass a rotation of 0, means that some calculation is happening here in the constructor, and it looks as expected there. So I think this is okay. Yeah, let's be a little clear that origin and tip are particles. Rotation 0 means tip is above origin. Speed, positive values are going to mean clockwise motion. I rarely add comments, but this is one moment when it's kind of important to specify what you want to have here. Make things clear, otherwise you end up at some point having to debug and remember what they are. And in this case, the code itself doesn't really explicitly tell these things. Maybe TypeScript could work to somehow make these clear that they are particle objects, but anyway, sidetracking here a bit. So the motor is moving this leg nicely. It's great. We want another leg in the Strandbeest here. So the right leg endpoints. The motor should have more things there. So let's check Peter's code. Now I'm actually gonna start explore Infinity's code, because I think that this extra space here, so 2 motors in this version, but the motors are in sync. I think that this version is clearer to see because of this separation. So nothing against Peter's version, but in that one, many lines connect to this one engine, and I think that what we see here is essentially the same thing, but the right leg is to the right and the left leg is a little bit to the left, and they only touch here a little bit. I'm not sure how hard it is to modify this code to make the motors a little bit more separated. So must be in main. Yeah, many things in main here. What does this do? What does this button do? Hey, it did it. So it's kind of intuitive. This code is a little harder to understand because unlike in Peter's code, there is no diagram there. But it became very clear to me when you can set the Strandbeest's properties like this, that the width is controlled by that. Otherwise, we can't control the width really. So no diagram, but clear to some extent. And here some messy stuff and comments, and it's normal when developing some things. Especially when prototyping, because you don't know exactly what you're going to get. Hello, gifted fingers. Right, so what do we have here? Many overlapping legs on this side. But they are connected to different parts of this motor. Oh, is it crankshaft? Similar to this. I want to give a good name to variables. And crank arm. Crank seems to be something. Lever is also something. Pivot is a name. Maybe we could have levers. So our motor is made out of a pivot and different levers. So this other point could be the tip of those levers. And yeah, Adrian, I use this red theme because I want to separate the code that other people contributed to this from my code. So I want to make sure when I'm looking at some code that I don't think it's mine by mistake, and it's on purpose, like jarring like that. And also for you guys to know that I'm looking at a different code base. But I don't really switch to that one very often. So, okay, the motor, endpoints. I think the motor needs to have origin as the part of the constructor. And that's it. And then we can say motor connect left leg endpoints the tip with a rotation of 0, a rotation offset of 0, something like that. So now our motor doesn't have the tip anymore, doesn't even have the rotation doesn't need that rotation. We just have this angle offset as a kind of internal thing that makes sure it's aligning to the top there. So the angle is 0. Angle 0 means tip above origin. And now we have a little bit different naming there, but let's go with that. And then here in the we have connect. So connect particle with an angle offset. So this is good, but tip doesn't come from that, and we're not using that word lever or crank in any way yet. We can group them as a lever. Let's use a lever. So lever. And the names were pivot and something. Pivot, endpoint, let's just call it like that. Or tip. Tip is fine. So tip and then angle like that. Maybe the length is useful. This AI thinks I should calculate it, but this distance method is not something that is supported there. I would have to do it some other way, and I don't want to. So let's do it like that. So now here we can have this levers is an empty array, and the length here, we didn't need it. We don't need it. And now when we connect the particle there, we create lever, new lever, this origin with this particle, and then the angle, this angle plus angle offset. This is fine. Yeah, good. And we just added this lever's push lever, and when we update, we need to modify the angle and then loop through all of the levers. So this levers update with this angle. And this code goes inside of the lever. So update with a given angle. And this code that I took here, it's like that. But let's see what this AI tries to do. Modifies the angle. This is not going to work as expected. We need to have a way to measure angle increases, not angle changes. So okay. Oh, hello, Juan. Long time no chat. And joint. Yeah, coupling joint might be a fitting name. Let's think about it. It might be a better name. I might rename it. I'm just thinking here. So each of these joints or levers get initialized to some angle. But this is, maybe we can pass here just the angle offset. So no, so the lever needs to know its angle. But okay, this speed value is what we could put here. Plus speed, and then I don't know what this is doing. Maybe it's good, I really don't know. But this tip location is the pivot location with this angle and this length, which we don't have, but we can calculate it again. So length is the distance between those. Okay. So now back here, we connect the levers, and when we update the levers. And this might be enough. Let's make a poll in the chat and ask what should be the name for this thing. Should we call it lever or crank or joint or coupling? Okay, so let's see how that develops. And here in the motor, this is fine, and the Strandbeest motor connects to that. Motor updates. Let's see, does this work? So back here after let's keep this one from Explore Infinity. Lever is not defined. Okay, this is good. And now in the Strandbeest, let's go and change here. Yeah, I don't like this. We have to do something about that. Connect also origin vector, this can be without the left leg endpoints. Like that. And we can put here right leg endpoints tip. Oh, that. No. Oh. Oh, okay. I did some mistake here when creating the motor. I replaced it with origin vector, but this is just a vector for creating the leg. So actually we do need some particle to hook it to. We should actually have all of the legs origins there. Yeah. Anyway, this kind of works now, and it's interesting. Okay. Coupling is 100%. Is it just Adrian who is who is voting, or are there more people? One vote. Okay. So do others think that I should use some other name than coupling or lever or joint or okay, now it's interesting. It's even, it's a tie. How I feel about TypeScript? I don't have that much experience with it. I think idea of types is really good because I miss them in JavaScript. So probably I would like it more than JavaScript, but it introduces some new things, some extra stuff that you need to worry about, and I like the straightforwardness of JavaScript. So it's only because you get into the project much quicker without, yeah. But I feel the origin is not handled properly here. So when we connect the lever, the levers should probably be connected here, created here. Yeah. Other than that, this looks really good. Let's clean up some code until we think about these things a little bit more. So I don't like this stuff at all. When we create the Strandbeest, here, so these properties, they are fine to be like that, I think. But here I would wrap them in an object like this. And that means here we can say properties. So, or lengths. Those holy numbers. Given lengths. So this is now an object, and that means we can do that, and we can do that. And put a true there, and reformat this thing. And these given lengths need to be supported by the leg as well. And we can do that. And do we ever use this A anywhere? No. So this is something that is not needed. These given lengths here can be like that, generate leg. And then the generate leg function, because this one, it can also have those given lengths. And generate coordinates from given lengths, it's fine. And then here, this uses the values directly. So I will destructure them already here. In the constructor, in the function, in the or let's put given lengths. And first thing that we do after putting P1 or even here is const that. So we destructure like this. And now we have access to them exactly like in the diagram. So A, B come from diagram. Nice. Now this name here, generate coordinates from given lengths, because the given lengths is also a parameter here. It's kind of okay to call it like that. And I'm gonna reduce some of the space here. So P4, P5, P6, P7, let's add the space here, P8. This looks very good, I think so. Nice. And here, this part, generate leg. We could just loop through the coordinates through the P's and create this, but then we don't know which ones are fixed. I think that it does make sense to say something like this particles is equal to p.map. New particle, and remove the second parameter like that, and then just say here this particles of 0 is static, set to true. We can also make a setter for it later. Let's see, but this is already shorter than before. And the sticks coming with the given lengths. Okay, here we are lacking these values, so we should destructure them again like that. Like that to create the sticks. Get endpoints, this is fine. Get tip location. I have a feeling this is not necessary anymore. So knee below tip. Don't know what that is. Something in the scoring. Yeah, I remember when we were trying different things, different configurations, some of them were wrong, they were intersecting, or the knee was below the tip or something. Maybe this is needed, but I think we can implement it easily some other time. Sticks intersect is very clear, and it can be made like that. But this get tip location now, it's used here, but the tip is coming from get endpoints, so tip is get endpoints and then the tip, so we can do that, and we can remove this unnecessary function from here. This has broken. I should have debugged more frequently, but it's not broken anymore, so this is good. And now this score path will go away somewhere. Let's see if it's needed. And the error, this is not the responsibility of the leg itself. So whatever error it has, somebody else decides it's an error. So it's yeah, some crazy stuff here also with scoring path, but this will go somewhere else, I'm sure. And scoring first draft, I don't want to remember things that didn't work. Scoring second draft, again, I don't want to remember things that didn't work because they didn't work. So I removed those. Sticks intersect, this will go somewhere else. So it's this scoring method or whatever. But otherwise, get endpoints, this is something we use there and outside, so it needs to be a public method. Updating things like that, it's somehow fine. Yeah, so the leg is better, but it's gonna be even better when we end this. How should we call it? Oh wow, 7 votes, and seems like so far it's liver is a good name. So I'm gonna keep it like this. But maybe later we can think about a better name if for some reason it starts to do other stuff. Benefit to using an object for the given lengths instead of just an array. Naming them A, B, C feels confusing. Yes, so this is my logic here. We do have in the leg file both approaches, right? So, okay, mutate also will go away. I forgot about that. And scoring and sticks intersect and everything. So we have both approaches here. We have the array used for P0 to P8. And we have the given lengths using an object with these names. The reason this is an object here and this is an array here comes from this diagram and comes from this video. Everybody is calling those lengths A to M, and not just in the diagram itself, in this table right here and so on. So the idea of keeping those variable names instead of renaming them 0, 1, 2, 3, 4, blah, 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 is for consistency. If somebody, if your colleagues or whatever say, hey, I found a better version, we replace C with 40, then you know what to do very obviously. It's coming from all these diagrams, all these experiments where people have used those. Of course, if this would have been a problem that a thing that we start building from scratch, nobody else has talked about these things before, then you're free to use the same thing everywhere. The reason I didn't use here, sorry, an object is because it's kind of redundant. I want to use the indices of these, like 0, 1, 2, 3 to 8, because according to this diagram here, they are called P0, P1, P2, and so on. Peter invented these points. My points from the previous video were a little bit different, but now I updated them according to this diagram which we have here. So the indices here are going to be useful because they refer to these specific points P1 to P8 that were calculated in P0 to P8 that were calculated in the diagram. But then when returning the values here, when generating the coordinates, this is an array. And that means that particles of 0, particles of 1, 2, 3, and so on will match the P points based on this ID directly. So if this P would be an object, it would have P1, P2, P3, and then you have to do some weird things to figure out which particle belongs to P1, or I don't know. So that's my reasoning. I could be wrong. And normally when building code bases, a very common approach is to do pair programming, like what we are talking now. People talk and there's the backseat driver behind you and say, I think it should be like that. And then, oh, well, I think it should stay like this. And then after the argument, one of the person eventually concedes, and then the code base is probably in a better state than it was previously because you thought about the issue. So glad to hear gotcha from you, but I am not totally convinced about these, but all these arguments make me comfortable that this is on the right path at least. So I have reasons for them. I'm not just doing it for no reason. Okay, and more people came there. Okay, Adrian, leg params, yeah. Leg params, you could destructure them like that. Am I not doing that somewhere? Yeah, leg params, probably, yeah, probably this is something from previously, and yeah, I could have named them here leg params and do the destructuring directly here, and then the constructor would still have very many things there. But I did it up in another place. Daniel finally arrived in the live. Yeah. And I will explain everything that the code is doing today when it becomes even better and working, because we're still cleaning stuff and improving the functionality. I still didn't get to the physics and the statistics, something that needs to be still done. When everything is ready, I will do one sweep through the whole code and explain it so that people can start playing with it. But for now, I think that the quality is getting better. Okay, yeah, nice to hear that you like some of the videos. Which ones do you hate? It's a real question. Okay. And let's format this one as well. So of course, now this part from here is kind of redundant. So I could say here 38.0 and B becomes 41.5. There's no reason for me to scroll so much here. And all the way to M really, and this autocomplete tends to be pretty good at it. I kind of trust it. I could also just copy the top part. Maybe that would be the nicest thing you could do in this case. So copy this from F and then do this kind of multi-edit here, and then you know that you are getting exactly the same values. So this this stuff with the autocomplete, it's sometimes doing suspicious things. And then for these other values that I liked previously and I'm using to test sometimes, I could copy the whole thing and put these inside and reformat this so it's an object. And this Strandbeest comes from my stupid genetic algorithm from last time, and I still have this possibility to switch through them. It's maybe not the best way to have the comment here, but I doubt that this is going to be a thing that lasts. So it's gonna go away at some point. Okay, and then origin vector where everything starts. Spacing, what is this? Ah, okay, in that optimization thing, we space the legs evenly somehow, minimum X and Y. Okay, some kind of capping values for those when generating random values. It's fine. Yeah, there are parameters there. Okay for now. And then generate legs for optimization, animate this, yeah, random legs next round. Those are things we worry about a little bit later. What I want now to do is this code works. So I want to make the beast look like that. And then release it because now it's hanging and these points are static, and then work on the physics. So that was the major issue last time, I think. Also one of the major issues. But let's first make it look like like these nice animations I'm getting from other people. So this lever is clear. And the other levers, yeah, in here. Oh, I need more legs. Left legs is, I guess, something like that. 3 of them. New leg origin vector given lengths, and this doesn't need to be there. So left legs is like that, many of them, 3 of them. And then we don't push anything here like that. We just say right legs with the true there. And now we can push both of them or just define the legs in this way. So we spread the first ones, then the second ones. And then these endpoints, so left leg origin, origin article, legs of 0 get endpoints origin, that's fine. This is the one that is being sent to the motor. And then we can loop here for 0 left legs like that. Left leg endpoints is that. Connect there, but this is going to be the tip. I don't know why it's making this mistake. So we get the endpoints for from each leg one by one. And the angle here, I think we have to divide 2 pi by 3. So so I times 2 pi by 3. And this is the same angle here. And now it's good. Haha, it's great. My segments are too thick, so I don't like them so much. They were thick because I wanted to see those colors well. Let's put a line width of 2. I think it's much more nice like this. Okay, then you're gonna like something I'm going to I don't know. Some eye-opener video is something I'm planning for the summertime after a big competition. It's about math stuff. Okay, so some things here still not proper. I think that the motor should have the origin particle all of the origin particles should be part of the motor somehow. The model larger. Because I also have that thing where I'm doing the genetic algorithm, I don't really want to make things larger because many of them should fit there. Yeah, then return to original size. Maybe I can do this hack where we do some translation. Or yeah, let's say that, and then do a scale of 2 and 2. And now my origin vector, let's see. Maybe we do like this. And then this origin vector, actually all the way to the top, maybe. Like that. And yeah, let's just leave it like this. And now you can see it more clear. And if I want to not do that, then I just remove those. Is that fine? Okay. Yeah. So releasing it now, and that motor, so the origin, when we connect the lever, each of the lever's origins also needs to be forced to be the motor's origin, really. And that would be the first lever's origin because it was defined based on those levers, or not quite, but the first leg's particle. I don't like this very much. I think that the leg should have segments coming from it, and then those segments be attached to the same particle that moves, that is part of the motor. So a little bit nasty thing here, but let's leave it like this for now. Think about it, and I want to detach the legs. So these static values that we put somewhere here, what happens if we keep just the first one static? So P0 now is not that one. I want this P1 to be static. So that's why the diagram is very useful. And let's see what happens now. I think it will collapse somehow. But so the reason this collapses is because these points, this bar here. So this one in the center, oh, sorry, this one I think stays still. Let's do that again. yeah, so P1 is still here, and it makes all the legs do some very strange things. But all the other ones, yeah, all the other ones, so this one is the static one, but this one wants to fall, and this one wants to fall, and this one wants to fall. So there's nothing holding these ones up. And I'm not sure how to fix this in a very nice way, because that bar should be extremely rigid. And I could add here some more segments, like connect this one with that one. Let's try to see what happens. So let's revert to this and now connect in the sticks. Connect P1 with P2, because then this forms a triangle here, so it should keep them from collapsing. So P1 and P2. I'm going to add it at the end here, P1 and P2, and I'm not giving it the length because I don't know what the length should be. But in the stick class, if there is no desired length, it just calculates the distance, so it does it automatically. And now it's a little different. You can kind of see the rigidity there. But because the P0 of one leg is not P0 of the second leg, is not P0 of the third leg, and so on. That's the reason. So P0, P1, and P2 should really be the same particles. Yeah, actually, the reason why they collapse is because they don't really know about each other. So somehow P0, it's a different P0 for each leg, and they are not connected in any way. They are not forced to be the same. P0, P1, and P2 should really be something shared between the left legs. P0 and P1 should be shared also with the right legs. And then the right legs should have P2 as a common point. So, yeah. I'm gonna do something kind of messy here, but maybe eventually we figure out some better way of doing this. So, origin particle, this one, I'm just gonna call it P1, I think. So this P1. P0 and P2. These are things I'm going to take from the first leg. So P1 is legs of 0 endpoints, origin. P0 I don't need the endpoints tip. P3 is independent for each leg, but actually it's important also because it connects to the right leg somehow. So this visualization is a little misleading because this one here connects to that one when they are attached. By default, that's how this thing looks like. This might be also interesting to experiment with. But basically, P1, P0, P3, and P2 are all endpoints that I would like to take from the leg and do some nasty stuff with them. So here, the get endpoints, origin and tip, I'm just going to have here P0 particles of 0, P1, P2, and P3. So according to this diagram, let's open it here in the other VS Code. P0, P1, P2, and P3. So we also take them out in the get endpoints call, and they will match here. So it's fine because they have some kind of clear names in the case of the lever. But then here, P1, let's leave it like that because the motor is built on top of this origin particle. But then P0 is that, and that, and that, and that. And now, for the other legs, let's use here left legs of 0. So the first left leg. And now I want the rest left legs. So this, there's no this here. It's local variable. So this left legs of 1, P0, I want to set it to this P0. I'm going to say set endpoints P0, P1, P2, P3, and the same thing with left legs 2. But actually, P3, I don't want to include it here maybe, because the left legs are offset. So P3 doesn't go there. It's just P0, P1, and P2. And I'm going to wrap these in an object because I want to be able to identify them by these names inside this set endpoints function. But then this right legs of 0 set endpoints I don't really need to take these out like that. So let's see. Right legs of 0 set endpoints. The right leg needs to have P1, P0 and P1 given so that they are attached there. So right leg set endpoints P0 and P1 and P3 because they are in sync. So P0, P1, and P3, and the other ones don't have that. But now this right legs of 1, I need the P3 of the left leg of 1. So left legs of 1 get endpoints P3, something like that. And this will be called P3, like this. And the same thing for the right legs of 2. Okay. And now we can modify this set endpoints, create this set endpoints function. And this particles of 0 becomes P0. So P0 and P1 are a thing that will happen. But now if P2 is given, so if endpoints contains P2, then we set particle 2. If endpoints P3, then we set endpoints of 3, like that. So this is one thing. But these sticks also need to be modified somehow, because the initial stick between these particles isn't there anymore. I mean, the initial part P0 has been replaced by that one. So this is annoying because I would have to look in this sticks array and figure out what is the index that corresponds to particle 0 and particle 1. It's very annoying, and I can make many mistakes. So P0, P1 is this L here, but the index here is, I don't know, 0, 1, 2, 3, something like that. So this is something that I would like to identify these sticks differently. But we do loop through them in several places. And I think I just count these now and then fix them. So I don't want to do too many things at once. I just want to get this to work, because if this doesn't work, I need to implement some other way. And this is really the fastest way I can test at the moment. So I'm adding here these indices, and that way hopefully I don't make mistakes. So what happens now is that we always have to replace the stick between particles 0 and 1, so this L. And this L has 11 index, so this sticks of 11 is equal to horrible. I shouldn't create a new stick. I should actually use the previous stick. Maybe that's something that we need to figure out at some point, but I will create a new one for now. And then this P2, if we do have P2 as well, then this P0, P2 has to be updated. P0, P2 is the first one, so index is 0. So sticks of 0, new stick, particle 0, particle 2. I don't need to give the value. Because it calculates automatically based on the positions. Actually, here I don't need to give these values because they are calculating automatically from those positions. Yeah, this sticks object, I think, has to become, this sticks array has to become an object, and then the key will be A, B, C, D, and so on, because that has a meaning. But let's figure this out now. So then this, if P3 is there, P1, P3 has to reconnect. So P1 and P3 is M, and it's 12. This is so messy here that this AI doesn't know how to auto-generate until I really almost write everything. But let's see what happens now. If I go here and restart, some disconnected segments are there. Yeah. Why is there just one leg on the right? I don't get it. The right legs. Let's remove these right legs at the moment. Focus on the left. I think that what we did on the left side, it's okay. These levers seem to bend a little bit. But because it's carrying all the weight of everything else. But this other triangle is here, so this should be the thing that stays horizontal. And it should stay horizontal if there are the same things on the right as well. So what I think I want to do is reintroduce the right legs, but keep only one left leg and one right leg. And now I don't do this with the second and third legs. And restart. So now something is broken there. The P3 connection and the P0 and the P3 connection doesn't work. Okay. So I'm setting the endpoints for the right leg to be P0, P1, and P3. These stay connected to the previous particle. So they are connected to a particle that is not even being drawn at the moment. So the right legs, they are created like that. But then setting the endpoint doesn't work for some reason for the right leg of 0. We are given the endpoints of the left leg. Yeah. 0, 1, and 3. 0, 1, and 3. And then 0 and 1 should attach so that this particles of 0 becomes that, and this particles of 1 becomes that. The original particles will be overwritten. So 0 and 1. And then when P3 is also there, wait. So P0, P1 is one thing that needs to be connected, this L segment, but also P0, P2, because P0 is a new thing. So the A segment also has P0, P2 also needs to go there if P2 is given. Right. If P2 is given, P0, P2 is necessary. Okay, but for P3, when P3 is given, it's not just this M, it's also a new P3 is here. So J and A, P3, P4, and P3, P6 is also important. So P3, P4 is index 9. And P3, P6 is index K. So is K, so index 10 there. Okay, now let's retry. And this bottom one, so yeah, P0 changed, and because P0 changed, oh boy. This one with the P0, P2, it doesn't have to connect to P2, but it has to connect to the own P2. Oh boy. Else, I don't have to change this one. I just have to do this one. Yeah, now it works. I mean, it doesn't work great because this system here collapses. And now the engine is trying to move everything up or whatever. But I think that the connections are proper now. So the physics is something we need to work on. So these collapse, which they shouldn't do. And then the engine there. Yeah. So let's try again. Or maybe we keep it like this simple with just two legs, one on the left and one on the right, and work on the gravity next and the physics. And when that is done, introduce the other legs and it should work. And then try to clean up that horrible thing with the indices there. Okay, sorry, I didn't check the chat for a long time. So Daniel was saying something. Observing the movement of P8. Yeah, and limiting it on the y-axis. It is actually already not allowed to go too much below. So there is the middle. You can see they stop here. So there is a limiting factor in the physics, a constraint for it doesn't go below this line. The center of this particle doesn't go below this line. So now it's trying to push it down, but the bottom is actually pushing back up. P0 track the movement on the y-axis. P0 track the movement on the y-axis. P2 will be forced to open. I don't quite follow. I think this came earlier. And I just lost now. Then Adrian was giving something, P0, P1, label A, length 0. Yeah, I'm sorry. I think that this is already, it probably has moved on, so I couldn't read those. I was busy with my own. I think you're suggesting solutions to the same thing that I kind of solved. But now I want to work with this physics thing. So why we have a broken axis? I think that's a comment because it was detached there and you noticed it, and I fixed it just now. Then okay, bits in the high, and then P1 very far from the floor. Let it settle. P1 is very far from the floor. P1 is static at the moment. I'm not sure what you mean by that. So P1 is static at the moment. And I don't release it because I know everything is gonna collapse. Or let's see what happens out of curiosity. So when creating the legs, we don't make it static. It's a test. Oh, something is still detached. The test revealed something. We are missing one connection. No, it's not supposed to be a connection. I'm just attaching this to the wrong thing. Let's see. So I'm attaching P2 and P3 at some point, but I don't need to do that ever. So or no, I'm not attaching it. Why is this not attached there? This indexing is driving me crazy. I think we need to fix the code so it's clearer, but because now it's so hard to look at these indices there and then down here. So P0 and P1, index 11, P0 and P1. If P2 is given, it's not in this case. So then it goes here, a new stick between P0 and P2. So the new P0, which is this one at the bottom, and the existing P2, and I see it there, so it's connected. Then the P3 case, particles 3 becomes endpoints P3. So yeah, and I see it attached here to the top one. So this J is there. And M seems okay. The M seems okay. So P3, P4, and P1, P3. P3, P4, and P1, P3 are fine. And P3, P6. It's fine. Everything is fine. But this one, so P1, P2, when is this one joining? Never. Oh yeah, it was the extra one that we created here at the end, P1, P2. It also needs to be there when we always P1 and P2. So here, this happens always. Let's take it out of the if, and this is like that. And then P1, P2 is index 13. So let's go below this one. 13, new stick, P1 and P2. And now let's try again. Okay, so it looks rigid. The friction stuff will need to be fixed at some point. But this looks okay, I think. Now let's reattach that leg, because that particle of the leg, because I want to see if the previous movement is different now. It's a little different. It doesn't collapse exactly in the same way as before. That connection has been done properly. Yeah. Yeah, Okay, I'm almost there. So let's see now, these rigid segments, they don't work. They are not very rigid. They do something here that they shouldn't do. Let's try removing the gravity. So 0, 0 for the gravity, just to see the engine doing its magic. And now you see these shouldn't move. I mean, this segment from this line from this particle to this particle, it should stay straight. But the reason it's not is because the forces acting by this engine are moving it somehow. So are twisting it, and that's why this angle forms here. So without gravity, the thing doesn't collapse because there's nothing pushing from the top, but this rigidity of these segments, this and this and this should really form a very rigid structure, but it doesn't. So I think that we do have some physics. We don't have physics class here, but for some reason it's in the leg. This is a problem. I don't like this at all. This rigidity is doing something. And then the Strandbeest, when we update, each leg works individually. And that's a problem in one way because, yeah, each leg has its own rigidity. It's updated in a way that makes sense for it, but then the second leg breaks the first leg. So really, here it shouldn't let the leg update. It should update each particle of everything. So this update function from here, I'm gonna copy it. It has many extra things that we don't need, but I'm going to move it here and say all particles. I need all particles from all legs. So all particles, legs, flat map, get particles. I don't think we have a getter for them. We just have the particles array and then the sticks array. So maybe we should have get particles, but I want it to get working first and then polish the code of something that really works. So leg particles, like so. And the segments, those are needed as well, all sticks, like that. And now for particle of all particles, update constraint, rigidity, it's not good in the leg, but it's not good anywhere. So rigidity goes away from here. And then this update function might be needed because we do have a need to have separate legs as well in that genetic algorithm thing. But now the rigidity here should be a parameter from something. I'm just going to put it again 50 as it was before and default initialization there. And then all sticks here, stick update, and constrain the particles so they don't go even after the stick update. But all particles is needed here. Tip endpoint, I don't need such a thing. Tip path, push tip. Let's just not care about those because they are something that we needed for statistics and we figure out later. So the tip path thing anyway has to go away from here. The leg doesn't care where it was. And now if I refresh, okay, so this line is much better than before because it's not updating first the leg on the left and then the leg on the right. So this is almost a perfectly straight line now. And it's on the right way. I think we're gonna solve this. So yeah, and then the legs here. When we create the leg, let's try removing that static thing. Let's see if it shouldn't walk. It shouldn't fall, actually. The reason it's falling, it's not because of gravity, it's because the engine pushes down. And now the sliding happens because friction is not there. There's no friction, and now the engine wants to push that way, so it moves it that way. And now it's floating there. It makes sense. So with some gravity, it's good. It's as expected. So now the engine tries to move, and it goes first to the left and then to the right and so on. And the reason it doesn't rotate is because these tips here, they lock somehow. No, this segment here is locking everything. So yeah, this makes total sense now. The next thing that we can do, I mean, this is not supposed to be able to walk with just two legs. That's clear. One thing I want to try just for fun is add the other legs and see if the connections look good. Yeah, I can't see anything, unfortunately. And they are not good. I can already tell they are not good because these tips should also be the same somehow. And some other segments need to be, yeah. Let's just keep two legs because the friction with the ground is something that I want to focus on next. And I don't want to add all the legs because I can't see anything. Adds too much complexity. But the structure like this should fall, should stick on the ground, and that engine should actually, I think it should make it somehow wobble from side to side. Of course, what it's doing now, it's completely stupid. But yeah, so adding friction at this stage is important because I want to understand what's going on, not because I want to get it to walk, because that's unrealistic. Okay. Yeah, I still have a lot to do. I'm doing good. Thanks for asking. No, it will not walk because there's no friction. So really, it doesn't have what to push on. It needs friction, and I don't want to add the other legs because I want to test friction in a proper way. So in the to-do list, again, for those who have trouble following along, the physics needs friction with the ground. I would try to see if the particle is touching the ground before and after updating. If the particle is still touching after that, it's reverted to the previous position. So, okay, it's reverted to the previous position. It's made static and sticks are updated again. Wow, many things. Yeah, so that was kind of my chain of thought there. Oh, hi, Himat. Long time no chat. And yeah. Yeah. Okay. So, can we implement this simple friction stuff with the physics? I really think the Strandbeest update this rigidity, gravity, whatever, a physics class needs to control all of that. Update all of those things and also tell it how rigid the things should be. The Strandbeest doesn't really know its rigidity, how much the sticks can deform, but the physics, the world can tell that. Of course, each segment, each stick could have its own flexibility, but the idea would be to have the simulation tell that everything is not flexible in this world, I think. So I want to add here physics.js and move some of these things to it, some of these responsibilities, and implement the friction there as well, because now it's kind of messy, it's kind of everywhere. And physics, new physics. And I use the canvas because I need to pass the constraints when moving the things around. So basically, this physics is going to update Strandbeest and the canvas. Yeah, I think we can pass it like that. But I think we can pass the context directly. Just because we want to draw it there. Yeah, we were passing canvas before, I'm not sure why. I think because the constraints were needed when moving the Strandbeest or something like that. But now the physics is going to update the Strandbeest, and yeah. And here we can say so gravity rigidity 50, something like this. And what we had previously, we had that, and also this gravity was a vector, which is fine. I think we can store the gravity here as let's just do that. And the update method, some object, maybe many objects, like if we will have many Strandbeests, we could consider many objects here. And then the canvas, I think the idea is just to draw the object there, or let's just work with canvas as before. So think about making the code a little better after it gets working. So here, let's just pass the canvas as it was before, but we don't need the gravity because the physics knows the gravity. And then objects and canvas, I want to use this approach. So back here, I'm going to pass an array of one Strandbeest, already thinking about that functionality. So now this updating with gravity, canvas, and rigidity, that should work. But really, the Strandbeest update function needs the particles and the sticks. So the motor updates, that's fine. The motor is not affected by gravity. Maybe it should, but yeah. Get particles and sticks. So get how should I call particles and sticks? They are like what is it called? It's called primitives. I guess primitives might be a word. But I want a motor here. Get moving parts. I don't know. And then motor. I think that this is fine. And then the update function doesn't exist anymore. So back to the physics. It doesn't tell the object to update itself because the object doesn't know how physics works. So here we do particles, sticks, motor, get moving parts, and then all particles, they're already in the proper way. So here I can say motor update. So it's best to leave the physics to decide how the motor is operating as well. And then this is not needed. And then particles like that. Now the force here, there can be many forces, wind, whatever. I'm going to put the gravity for now. Particles should be constrained in the canvas width and height. That's fine. Rigidity is this property from here. And all the sticks are affected by it. And then again, all the particles like that, constrained. And this is not needed anymore. And now the physics should do the same thing as before. Particles is not iterable. Oh. Ah, we are not drawing the Strandbeest. So where were we drawing it before? Physics update, canvas is there, and the objects. Update constraint, particles, they have a draw method. Leg draw, stick draw, particle draw. Okay. Let's try removing this scaling stuff from previously. There might be, wow. Wow, I'm getting, okay. Oh, oh, doesn't work. Why is the gravity a canvas? Oh. Okay, now it should be as before. Yeah, and the scaling was just fine. Okay, so now it's like before, but the physics, we have now room here to do creative stuff and figure out which particles are in contact with the ground. My brain power is starting to run out. So I hope some magic happens and we can progress very quickly. But I think after this friction is implemented, things should move faster. Let's see. What do you mean by wheel, Nathaniel? I don't get it. Joints and arms, legs. Yeah, I actually had a poll up there about how to call the things, and this lever seemed to be the most voted, and I went with that. And Daniel, many things are weird in what happens here. Okay. So each particle is being constrained into something. Let's do this. Let's say that. Okay, right and bottom is the only thing that constrains it, apparently. But anyway, good to know. So then this log x is like that. And if the location after clamping, it was restricted by something, then it changed. If it's different, then it changed. Okay. Return changed. And now, back in the physics, we update by gravity, then we update the sticks, and we do the rigidity. Let's make the particle itself this changed is equal to that, so it doesn't return it. So not changed, because change happens in the moving, but constraint was constrained. So this was constrained. Update is static. Constraint was constrained, depending on if those values are different. And in the physics, the particle shouldn't know about that. I liked the previous version with returning here like that. So then in the physics, let's take the particle and the index. And here an empty array, and then was constrained, particle constrained like that on the canvas. And if it was constrained, I mean, we just push that into were constrained so that we know that that has happened, but not push. I want to use this exact index like that. And here, so this is fine. And here, the same thing. So like that. And I use the same way of looping here with the index. I think you can use a for of also, but now it's that was constrained. And now every time we update, I want to log these. So everything is false, but at some point, some of them are true. This one is true, this one is true. Seems to be the last one from the first leg and the last one from the second leg. So they are fine. It's not was constrained. Okay, and I think we can actually have an attribute here because I want to draw it. What is this marked? I don't think this is used anywhere. So this was constrained. then let's make it gray. And now you can see them here. I don't know why that one is not. Maybe it's not constrained because it could be floating a little bit. And actually this line does have a small tint to it, small tilt to it. This part of the structure is lifting it up a bit. So this is fine. And this one here on the left is actually floating up. So the gray ones really seem to be touching the bottom, the ground. And the idea is that now these particles that were constrained let's try it like this. So now the indexing doesn't work here because it should be part of each object. So let's move this back here. And now the indexing should work, should match to the particles here. But then after we're done with this, if the particles were constrained, let's just try what happens like this for if was constrained, I just put here old location, no, location is the old location. And let's just see what happens. Or the reason for all the indexing stuff is that I would like to separate it at some point. So were constraint of I. And I don't need that logging anymore. Let's see if that triggers anywhere. It does, but it doesn't work. Yeah, it's not good because I should really know the location before starting to update anything. So, oof. Old particle locations like that. And then location is old particle locations of I. Hehe. Yeah, it's something. So you see it gets stuck there. But then as soon as the weight goes on the other side, it gets unstuck. So the system actually works. I will leave the is constrained thing here because there was constrained. I think it should be is constrained because now we are checking as it is at the moment and we are drawing it as it is at the moment. Yeah, this is good. This is good. I think we are almost ready to get it to walk. Let's see. I will just try all of a sudden. So 3 legs on the left and 3 legs on the right. What is that thing doing? Oh, wow, crazy stuff. Okay, I refresh now. Please work. My brain power is running out. Oh boy. It's not gonna work because we didn't attach this point to the other leg points. But let's see some crazy stuff. It's so creepy that I like it even if it doesn't work. Nice, really nice. Okay, so let's try 2 legs because it's maybe easier to see. Origin, the motor is... I don't even know what I'm looking at, really. It's so complicated to say. Let's try no right legs. Okay, it doesn't work. Yeah, it's trying to do stuff for the right legs. And whoa, 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 whoa. Many things here. 3, 3, and we forgot everything here, so... No. Some disconnected segments are there. Let me try to make these sticks thinner. Maybe 0.5 because we have the double scaling. And I would really like to spend a little bit of time to color them differently, but I do see here some thickness. But yeah, so those points should be attached. Those particles should be attached. They are on the left, but they are not on the right. Yeah, so, and also some discontinuities here. I'm not sure what that is about. But I have a suspicion. What we are doing here for the left leg, so setting the endpoints like this for the left leg, the left legs of 1, left legs of 2, these are set according to left legs of 0, but the right legs of 1 and 2 are not connected to the right legs of 0 in the same way. So I think that this is the only thing that we still have to do. I'm just gonna be messy, and I really hope I have time to fix this. So right legs of 0 now here, and 1 and 2 should be the same like this, but on the right legs of 1 and 2, using this P0 as underscore P0, and yeah, like that. And I'm really hoping that this works now. And P3 is not needed anymore here because it was needed to connect the left to the right and so on. Almost. I see here improvement, but something is still disconnected. Something is still disconnected there. What is disconnected, and why are those angles not where I expect them to be? The initial start angle there, let's say animate. So I don't request animation frame, I just get the first frame. These initial angles are not good. Where are we generating the legs? Let's undo this stuff. I comment out everything here because I'm worried some glitch is happening. So this is initial configuration here. I think also after the physics update, so kind of. I don't want that. I want the legs to be drawn and then return this function without the physics. All of them are overlapping, and that shouldn't be. So back to the Strandbeest, when we create the legs, we connect them to an angle. The tip should be at an angle. Yeah. So then the motor connects it with this angle offset. Creates the lever with the angle offset. And then the lever update, I think this is where the problem will be. This angle, okay. This doesn't get called. Now it's good. The update of the forces is going to probably force some things out of place here. So if I go back to the beginning and remove this return and also this thing. So it's reverting to its original position, I think. Okay. And let's try restarting the animation loop now. Oh, wow. It broke apart like completely for some reason. Let's try again 1 and 1. Why is it detached like that? Ah, I commented out these. Dude. But I don't get it. I see that some particles are not connected to something there, but I really don't. Okay, it's obviously the connection to the motor's origin there. So P3 to P1 on both sides. P1, P3, why is this not there? P1 to P3. Or basically this P3 oh. Let's remove this one because now we do the things relative to this right legs here. So I think one of the particles is going to be overwritten here and then again here, and then the ones overwritten here disappear. Yeah, but they are not attached properly, so they should attach to that P1. So the P3s from the other ones, leg 1 set endpoints, P3 is not there. Why is the left leg not attaching P3 as well? Left leg, I thought that I'm attaching that. Yeah. P3 has to attach to the new P1 always. It's not attached, it's not part of this rigid structure, but it's something that we forgot. So P3 should attach to P1 always. That's it. In the leg, set endpoints. So P1 to P3 always. And when we are doing it P1 to P3 only here. But it should be always. Yeah, I don't know what's happening, but something's happening. So let's remove this a little bit. Let's debug so that this, when we draw the legs, we draw just the last leg. Or let's reattach those. That one in the middle and see the movement. There are some problems. This point should be the same point, and this point should be the same point, and this point should be the same point. But it doesn't seem to be the same. And this rigidity is also a problem. So these particles here, let's try with 2. Maybe we see better like that. These should be the same. And these, they look like they are the same. So the second, oh boy. So this P3 point in the ones here, like it should be the same. No. So the right leg, this has its own P3, but this P3 should be the same as that P3. Crazy. So P3, left legs of 1 get 10 points P3. Yeah, this AI figured out. So the P3 of the right leg of 1 has to be the same as the P3 of this one. And let's see quickly, does it really happen in the set endpoints? So if the P3 is there, particles P3 is that, new connections are made, I think it should work. I don't see them anymore behaving strangely there. I think it works. So back here, reintroducing left legs of 2. And the right legs of 2 has to do the same thing with this one from the left legs of 2. And last but not least, let's put this back to 3. Now this looks okay. Yeah, now this looks okay. The rigidity is something that is somehow, this needs rigid segments here. Or, yeah, it might be one thing that we need. So the rigidity between these, there is nothing keeping these levers at the same distance away. And also, why do they start in that position? Okay, they start in that position because they are initialized in that position. But when we initialize the legs, so something crazy is happening here. They are in the correct position, but the rest of the structure is not constructed appropriately. And this is because when we generate these legs, we don't use the rotation. And now, updating this. It's modified by gravity, and you can see these levers, they are falling down and this angle is changing. So that's why we need something for the physics to work. We need this triangle to stay the same way. If not, this is just going down like that. So let's remove this once again. And add those constraints. So those constraints are part of the Strandbeest itself. The motor has the levers in it. I think the motor can have also those sticks. So when we connect something here, keeping levers spread apart. Okay, so these sticks, every time we connect and every time we add a new lever, before we add it there, we loop through all of existing levers for I don't need the angles, I just need these sticks, push a new stick from the existing lever tip to the lever tip. The distance will be automatically calculated. Add the new lever. Create the first one. Everything is fine. So then in the Strandbeest, when we get all the particles, the particles are all there, but the sticks, we do that. What did this AI want to do? No, I don't need that. Okay, now again. What? What? Why is everything static now, and where are my missing sticks there? Okay, they are missing because I'm not drawing them. So if I remove this, I have the same thing as before. The constraints work, everything is fine. But when I add those sticks, everything is... What? Where do they want to move? I suspect some explosion stuff is happening there, so physics. Let's disable that thing with this. They just, I don't know. What's happening? We've added some more sticks here from the motor updating. The sticks from everything are affecting the particles. Let's also update this so that the drawing of these legs is done differently. So let's do the initial thing here without animation like that. And then I don't see those because we are drawing the legs, those that we should have removed a long time ago. But physics, Okay, I do see here this triangle appearing now. Everything gets constrained for some weird reason. I don't understand it. But yeah. Wow. Okay. I haven't been reading this for a while. Let's have a 5-minute break and check the chat and then try to finish up. It's not gonna be as clean as I wanted, but I think I can figure it out if I debug a little bit why those things are. Let's see. Why those things are getting constrained like that. So, okay. Yeah. It's strange that I did change that part with the physics. Yeah, it would be better to pass just the info it needs, so I don't have to pass the canvas to the physics. You're correct. But I want to refactor the code when it works, so I'm doing a little bit sloppy things now. You're totally true. Index twice in those loops. I really don't know which index we are talking about anymore. It might have maybe you wrote those things a very long time ago. Yeah, I really want this to have to work. And the second thing, I would like it to be clean. Somehow, I would really like it to be clean by the end of today. But unless some magic happens in the next 5 minutes and I figure out how to do it, if I figure out this bug, why everything gets constrained, then I think it's easy, the rest of the stuff. Peter was there also, but he wrote something and removed it, it seems. Peter, I stole your code in the beginning. What? What happened? think this rigidity is actually there, but this debugger doesn't show me. Yeah. Okay, 113 sticks. Something is weird there. Why so many sticks in this motor? Oh, oh, oh. When we add the motor, we connect very many things, and some of them are 0. Because it's the same point connected to the same point, and I think that glitches out the physics. So motor here, when we connect, maybe the motor sticks shouldn't be the motor sticks after all. And maybe they should be in the Strandbeest like this. So what we really need to do is take the tip of, for example, the left ones. Let's just call them sticks. Left endpoints. Do we have the origin somewhere? Yeah. So from the origin to left leg 0 get endpoints tip. Not the origin. I don't want that. Stupid. I think the AI was doing something right. So the first tip to the second tip, the second tip to the third tip, and 0 to 2. I want to keep this ascending order there. So these sticks from the Strandbeest itself get moving parts, doesn't get them from this motor. It gets it from these sticks. We push them like that. The motor, I don't think we need it. So now in the physics, we get those moving parts or whatever, get all objects, get moving parts. We don't need these motors, but the sticks, for each object, we get the moving parts and the sticks. So the object is Strandbeest, for example. There could be many other objects, or different looking Strandbeests. So this adds to the sticks also those extra ones, so not just the ones inside the legs. This is fine. So back in the physics here, particles, sticks. We don't need to push anything more here. And the motors, I don't. It's fine. I need the motors. I need the motors because of that update now that is happening. So get moving parts in the Strandbeest has to return motors. There's just one motor per beast. I think we keep it like that. So motor, this motor. And here the motors may be many from many beasts. And then here in the first one, we draw everything like that. Restart. Okay, it's better. I see the contact point there. Let's remove this and debug the normal animation kind. So actually these scores and whatever, I don't need them anymore. So update and then draw, and then these scores and everything I'm going to comment out because we might need them when implementing the statistics. But Okay, let's see what happens when we detach the that static particle of the leg. Wait, should there be some... Let's open Peter's version again. No, they are proper, I think. So each of them are, the left and right mirrored versions are attached to the same one. I think the only reason why this is not walking okay, something that must be this rigidity. So how about increasing this one to 150? Something doesn't look right. I think there might be some connection missing, or yeah, something is wrong. Yeah, I think we are very close. I think it's gonna work with that. So some connection missing. Here, these things, they don't all connect there. So they collapse. The left and the... So the Strandbeest, when we construct it, the left P2. Why it doesn't work? So I'm setting here P2 from the first leg, from the left leg. I'm saying that the left legs of 1 and left legs of 2 should have that P2 from the first one. And maybe it does. Okay, but then the P2 connections have to be remade. That's it. That's, I think, it. So this B, C, D, A, B, C, D connections. Please be it. It must be it. It must be it. So set endpoints. B, C, D, E means indices 1, 2, 3, 4. If the P2 is there, then the particles are that. But then 1, 2, 3, 4 need evaluation. So calculating, regenerating the stick object. So this sticks of 1, a new stick between P2 and P4. And then 2, 3, and 4 between 2 and 6. 3 between 2 and 5, and 4 between 4 and 5. I have a good feeling about this. Better be good. Yes. Yes. Let's see what happens when it touches the wall. Oh, it's so slow. I'm curious what it does when it touches the wall. I think it might get. I don't know. It will get stuck there somehow. I don't know if it tries to climb the wall. Yes. Yes. It got stuck in the wall. Okay. Interesting. It bounced back a little bit. It's funny. When the wheel rotates a certain way, it actually starts pushing back. Nice. Nice. Oh, what rigidity do I really need here? Seems like it matters. Let's put 500. What happens now? I think the previous around 200 something was fine. The points move back like this a little bit, and I think that's normal. Let's try 2000. If we would make somehow the points that are almost touching be still touching. So the reason why it's sliding like that is because it's I think too sensitive. Let's see. Now the rigidity is so much that while loop is really yeah, so everything is so rigid that the system seems to need a little bit of how to call it, this kind of flubbiness, so that it touches the ground a little bit more, but not too much. Like if the rigidity is very low, it really bends the sticks. It starts to collapse eventually. So there is a kind of a sweet spot there. And I think this is nice because it's very similar to how the structure would work in the real world. But the sand, it's a thing. The sand forms some kind of groove when the Strandbeest touches it and presses on it. And then in that kind of small hole like this, it can push backwards still on the sand. So it's not exactly, we're not modeling exactly what it's there. Anyway, I'm really curious what happens with my stupid coordinates from here. So I have to try this out and have a laugh. Yeah, it goes backwards. Very clever. Yeah, stupid coordinates. It doesn't work. Anyway, back to the real ones. We don't get to the optimization yet. But what I want to do is clean the code a bit. So here, in the leg here, there are some things that can be done much better. So I don't think we need this anymore. We don't need A, B, C, D, E, F, G, H, I, J, K, L, M. And this 13 was between particle 1 and 2. So 1 and 2. Yeah, we added that one for stability. So we could call that one something else. But I think we don't need any letters there, any lengths past there, because now we do have the initialization from Peter's code, and it's perfect, and the length that the stick has when it's created is going to be the one that it should have. And these given lengths are also not needed. We can actually remove from there. We don't need points to be static anymore. We might, when we do the simulation, if we really want to look at that path again, but it's not going to happen from here, so we don't need that. And now these sticks, I would really like to give them letters, because sticks of 0, 1, 11, and so on is the stupid second indexing that I did there. So I will change this to be an object. I think this is worth it. And this is A, and this is B, and this is C, and this is D, E, F, G, H, I, J, K, L, M, N. N is a new one. So N is something that we don't have here, really. But I think I should update the diagram. So maybe just a quick edit here. And then Okay, so this was Peter's version. And now we have a different version. Maybe this A could be moved to a place where it has more space. And I think the font size should be also a little bigger. Okay, now it's good. I don't need that edit anymore. Okay, so these sticks are now an object. And that means that I have to fix some things. So here, I could say, so what do I need to change? I need to change sticks of 11, 1, 2, 3, 4, 0, 13, 9, 10, and 12. Let's just take all of them out. So they are the sticks. And then 11 is L. Just L. No, it's maybe it's gonna work. So just L instead of 11, and then 1, 2, 3, 4, this is B, C, D, E. Zero is A. 13 is N, this new one. 9, 10, and 12. 9, 10, and 12. So J, K, M. I don't think it's gonna work, but it's fine. So this sticks is an object now. The leg update, okay. And these sticks are in an array. They like that. And get moving particles. This we need to do that to get the array there. It's broken. Yeah, okay. I think that's not gonna work because the not because it's a constant. I mean, even if you change it like that, it breaks because we are not modifying the value in this object. We are reassigning some variable here. So I think we need to do that. So to everything, this and that and that and that and that and that and that and that. So and that and that and that. Forgot this one. Yes. So this is better because now the indexing, we don't have the double indexing anymore. I think this is very important. And we can remove the stupid indexing from here. So let's just remove all of them. No. Okay, getting better and better every time. So good that it still works. Full PowerPoint and the image editing. Yeah, I guess I did that. Right. So I got more energy. Somehow getting this working was great. So, many things are better now. Drawing the Strandbeest, I really think it should be its responsibility. Okay, it is. No, it's not. Why isn't it its responsibility? I don't get it. Why did we make this code here? I don't remember, but maybe some debugging stuff or whatever. But I think that this should go there. And in the Strandbeest, we do a draw method. Need that. They have the same structure. So Good, much better. So now the main file is clear the rectangle, update the physics, Strandbeest draw, and that's it. And we are ready to also do the optimization. I think so. So I will. Okay, there was this comment before that I do have prettier here. Sorry, I'm reading bad comments back and forth, but I'm not formatting automatically on save. But yeah, I think Adrian was saying something about the physics doesn't need the whole canvas there, and that's true. So physics, but then the particle, it's constraining itself. The particle, yeah, right and bottom. Why? Well, let's do also for the left. So nothing on the top there. Okay, and going back to the physics. So width and height, I guess we could do that. And the constraint here would be 0 width and height. And 0 width and height. And canvas width and canvas height. Okay, and to test if it works, we can always go to the Strandbeest motor, put it in reverse. Haha, look at it go. Let's see if it does what I want it to do. So, it's even further away. What happens if I make it 4 times faster? It's doing this interesting stuff. This Michael Jackson move. Yeah, this I really think that this ground is so flat that it's causing a problem. I really wonder, I haven't really checked the original video, but I really wonder if when Adam Savage made his thing, he did put something on the bottom to make it softer. And I think, I don't know. I remember watching the original video where he did this very long time ago, probably when it happened. And yeah, even shoes here. Maybe he's talking about that, I really don't know, but I think that it's just too flat. Okay, and then it's fine there. Good, very good. Let's move it back to the right, but make it twice as fast. And I'm curious also what happens if I increase the gravity. Let's say 5. It breaks it. So the leg breaks. It's too heavy now. Yeah. And a lighter gravity, maybe 0.5. I wonder if it starts to bounce up and down with some very low gravity. I would expect that to happen. Doesn't bounce. It's okay. Anyway, I think the 1 was just fine. And it really feels like this movement. So this motor is really yeah, this motor is really let's try something real quick. Not updating the motor. I want to see if wind can have an impact. And I'm gonna test just quickly because I don't want to spend time on that. But I'm so curious that I need to test. So motors updating here, I don't want that to happen anymore. So it stays like that, it's normal. But what I will do is I will change the gravity to have a horizontal component. That's so great! That's so great! It moves because of the wind. So, not because of the wind, but the gravity has a horizontal component, so the gravity actually now pushes that way. So it's the same thing as having the whole canvas tilted. So so kind of like that. I don't plan to keep this, but basically it's not falling because it's pushed by the wind. It's falling because it's on a hill, and this is because we are not clearing the canvas in the proper way. But I don't want that now. Wind can be implemented very easily if I really want that. But look at this. It's moving not because the motor is pushing, which is a different thing, really. It's moving because of an outside force applied on the thing, and it actually looks like it's pushed by something else. It doesn't have the same thing as before, that the motor was pushing it and forcing it to somehow snap back. But now it's kind of trying to keep up with the wind. Like the wind is pushing it and it's moving forward so it doesn't fall. This is great. I'm so happy with this system that we have, because we can have also this implemented in such an easy way. So you can play with this idea. I am going to put the motor to Let's see, what do people say? Like an escapement movement, like in a watch. What is that? What's an escapement movement? Kind of. I won't say it's not. Kind of. It does come to mind when I see this. Wow, this is so nice. Okay, so now the motor is off. Maybe we can have components for the Strandbeest, like parameters for the Strandbeest. After these, we can have something like motor use motor set to true, something like this. Let's okay, maybe at the top. So use motor is set to true, and now the Strandbeest. Okay. Physics. Should the physics move the motor, or should the Strandbeest move the motor? Maybe it should be the Strandbeest. I don't know. But let's see here, use motor, and by default, let's say false. I think it makes sense to have it without the motor, since the original ones are not. And this motor, so if use motor, then we do create these elements, connections, whatever. Otherwise, we don't. And now here, use motor is true. And in the physics, motors for each, blah, 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 get all objects. So I think if motor, then we update. So now it's moving because the use motor parameter is set to true, but if it's false, it doesn't move. And let's have also one for let's put the wind horizontal like this. So now we can pass to the physics gravity and wind. And the rigidity is going to be as this wind like that. And update objects, gravity, it's affecting like that. But I also want to affect by the wind, so maybe we do that. And I think this should be like that. So now something breaks. Oh, okay. Now the wind is blowing it. How about we blow it in the other direction? And now we turn the motor also on. So it tries to go right. The motor tries to push it right. But the wind is so strong that it tips it over. This is great. This is great. Wow. Okay. Use the motor. The wind is gonna be empty, and I just rely on gravity. So same as what we had previously. But this is really nice. So now let's clean up everything as much as possible, starting with the simpler ones. So vector, this looks good. Utils, do we use things? Clamp we do use, distance we do use, average, we never use average. Interpolation we use a lot. So it's important. Compute area, we don't use it in the right place, but we will need it for the scoring. And compute length of the path, I think it's also needed in the scoring. So utils is fine. Stick, desired length, we never use this constructor anymore. I think this still works. Yeah, everything still works. So the desired length is important when we do the update. I don't know why this is here. Is anything needed? Color coding goes away because we are not because the error is calculated based on that. But we don't need that. So the error is going to be with length instead. And do we have a distance function also in here? Let's see. So particle distance function, okay. So what's all this stuff here? This doesn't need this scaling anymore. So you can see these purple in this case are there because we are interpolating from orange to red, and the error is bigger than 1. Yeah, it's bigger than 1. So maybe now they become more red. And I think we can do this from 60, so it starts as yellow. It's kind of ugly. I don't like. I think that's why we used 30, but maybe 20, a little more. I'm sorry, 40, a little bit more yellowish. And now these become a little clear that there is tension in these sticks. So let's put here times 0.5, 0.3. So you can see where the tension is happening in the segments still. I think this is a nice feature to have here. Good. And now, so this, we don't need to update if the points are static. We don't really have static points at the moment, but we will have in that optimization, and then intersect another stick. This is something that isn't used at the moment, but it was important to filter out bad candidates there. Okay, this should be fine. And the drawing here, color is not used really. Nice. And when drawing the stick, second one is the align with. Okay, the hue, these things, I don't have a good brain now to think about good naming, but let's put a comment here. Color from yellowish orange to red, high error, low error, something like that. Okay, Stick is done. Particle, location, if it's static or not, updating the forces, has friction. This is not something that we use. We can remove that. Velocity, we calculated from the old location. Okay, it's not the Euler integration, it's this Verlet. I remember we did that. Constraint left, right, bottom. Clamp location is constrained. We just need this for drawing purposes. But we could also do this externally somehow. Yeah. So similar to the stick here, if they are intersecting, if this intersected, also for drawing purposes, it's not really the right place for it to go. I think that something else, the physics that checks these collisions will do that or something. But it's not the end of the world. It's decent. Back to particle is constrained. So that's if the friction will be applied or not. Location X, Y. Old location goes to this location. Why? It's preparing for the new one. Yeah, I think it's fine. Distance to another particle. Is this used really? Like so this used like that, to another particle, dist like that. We can just say dist P1 and P2 there. And here the same. And that's it. I think that in this one we don't need the method anymore. Yes, back. Good. Yeah, I should go to the beach. um, I mean, if you want to have a Strandbeest that maybe puts it on a wheel, on a maybe have a planet in the middle like a circle, and then it could go like this around the planet. That's something nice. I would like to see that. I don't think anybody else has made such an animation, even though these are very popular things to play with, I think. So why not have gravity like that? It's cool, I think. That could be such a nice like a loading screen or something. Okay. Um, right. So we have this, we have that. This is a scary one. Stick is, I think, final. This intersect is not used, but it will be. Particle looks good now, so nothing really I complain about. Motor. Origin is a particle. Tip is above the origin. Clockwise rotation. 2, 2, 2. Yeah. And the levers connect. This really should be called add lever, I think. I think that that's something better. Add lever because it modifies that. This the particle exists there. It's part of the leg generation. So yeah, let's just call it like that, and then say here tip is a particle. Angle offset is clear. Update, modify the angle by this speed. Yeah, and the levers do that. This angle is not needed, is it? Yeah, it's not doing anything anymore. So this is the initial angle. I think we can do this and it's clearer. Let's just call it angle and good. So this is also done. Lever, pivot, tip, the distance between them. The angle is given. The tip location. Yeah, so we need to modify the pivot and tip are particles, and we need to force the tip location to be different. No, we don't have to do that anymore. We fixed it some other place. We fixed it because we generate now the leg with the rotation. So it's already in that place. This thing that I've done now was that was here. It was some fix from previously, but it wasn't a good fix. So now I removed it, and now it's fine. Angle is like that, increasing by the speed. Nice. Lever is done. Leg. Oh boy. So given lengths, rotation, and if it's flipped or not. The origin vector is set there. Tip path, this shouldn't be here. Score shouldn't be here. Discarded. I don't even know what those are. They need to go away. And mutate. This doesn't even work because these are different objects here now. Score path also has to go away. Sticks intersect. Very strange. Yeah, that also goes away. So many things here go away for the genetic thing. And generate coordinates. These are those lengths from the diagram that Peter drew. And let's add also n now. No, we don't, because n is coming later. These were fine, so there are Peter's descriptions for what these things are. We get the points. They're indexed in a proper way. Generate leg gets this it's weird to call it X scalar, but Peter called it direction, I think. Might make sense. I tend to call it direction like this also. Then particles, yeah, set endpoints. So this is fine. I would like to group all of these things that happen always like that and like that. And then if endpoints 2 exists and if endpoints 3 exists, then those update as well. Wait, no, something broke. You can see here something broke there. Amazing that it still works, but these particles change in some order that is somehow important. Now it's not broken anymore. It's very important to test and be very careful when testing these things. I don't have energy to look into it why it needs to be like this, but particles 0, particles 1, particles 2. Yeah, it's like this now. Anyway, it's a solved problem, so that's good. And then get endpoints. Where is this used? So Strandbeest points with the tip, with the P1 and everything. Okay. This is not really needed here, this tip path, so this goes away. And this everything will go away there. So I think I don't need to worry about that now. And drawing the leg. This is not needed at the moment. It's not needed at the moment. I don't think it's gonna be needed if we are smart about implementing the experiment with the genetic algorithm. But let's see if I remove it entirely. It's easy to re-implement if needed. So it's not used. It's fine. Okay, so leg is decent. And Strandbeest, given lengths, use motor, left legs, right legs. The angles, we take out the legs to be somehow easily iterated through. Origin particle. Oh boy. Yeah, so we need to do this. We need to do this so that making legs share some particles and sticks. Connecting legs. This is much better explaining what's happening. So now the left leg of 0 endpoints. Okay. So this is shorter. Still works. Setting the endpoints of left legs of 1. Now, I don't know how many legs this will have. It's a good idea to test here if left legs length works. And then the right legs, same thing here really. Right legs 0. Something broke. It should be P3 here. Okay, good. Yeah. And then this not needed anymore, it seems. But this one, if the right legs is greater than 1, so it's really only possible to do than 0 like that. Okay. In this case, we can say that. Okay, a little nicer. And then set endpoints here. Okay. Still works. Good. And these sticks. Okay, still works. Now I really think this should be the same and it will work the same. Nope, it doesn't connect it there. It takes it. Oh, okay, I get it. There's the broken thing. There is the more functional approach. And here, okay, I'm over time by 1 hour, but I think I would like to keep it up for 1 more hour at most because I'm actually cleaning this up and my head seems to work. Yeah, Tom, that's what I meant, that the gravity can be split up to X and Y. So I think I demonstrated something about that. They don't collide because we don't check. We don't check any collisions between them. But that's a good idea. We should test that we can add multiple. I think this became more general, but zero, 1, 0, 2, and 1, 2. I think this is equivalent, so we can shorten it even more. Yeah, everything seems to work better. And if I would have a clear brain right now, maybe the whole logic here would become easier to explain, but I don't. And I'm not gonna try to do that. The motor, origin particle, going through the left legs. We are creating the levers. Ah. The levers now come here with the endpoints. I guess no, we need this code is the same. Same angle. Lever to the tip. I think I want to separate it into two. Because I don't know how many right legs we have, how many left legs we have. And somehow it's better for me right now. And I need the eye for this angle. Yeah, Peter, I did, and I stole your code. Hi. And it's working, and it's working so nicely now. It went very well. So we have this moving with the physics, and we're using a motor now, but you can turn the motor off, so then it just stays there. But you can add some wind into the system, and then it pushes it in the direction of the wind as well. I wonder what happens if I put the wind. Well, I don't play with that anymore now, but that's also possible to do. And the friction is kind of solved, but in practice, what happens is that the creature on the sand, is making a dent in the sand, and then somehow there is some sliding motion happening here when this is a very rough surface. But yeah, it's moving with the physics. I took your leg. So this is these comments here are yours, and you're gonna recognize them. And a lot of redesigning. I'm happy with the code, but I still want to make the simulation. So somehow the brain seems to be working today, and we don't need these legs. So I'm now cleaning up the code and preparing to create the simulation of each individual leg, like what we had last time as well. And I don't think I will be able to optimize very much, but I really hope that I can make a separate page for that simulation and clean this one up. So the physics is like that. This origin vector for the Strandbeest is where it's gonna be created. Let's just say origin, because we see here it's a vector. animate, and then these are not needed here at all, so they will go to the other thing. So let's create a new file. Genetic HTML. Let's say genetic HTML. I'm copying everything here. And now I can clean up this part. So really, I don't want that anymore. This input with the mutation rate and whatever, and the next round button. So in the index, I don't bother with these things at all. We don't need such functions here. The animate is as simple as it can be. Physics supports multiple objects here, so I think that's gonna help. Generate random leg, next round, these are not needed, so cleaning up even more. This is fine. And now the other one, genetic HTML. So this has those things there, and I don't want to see this one anymore. I'm done. Is this some error? No. No problem. Okay, so this genetic HTML, I need these things, mutation rate and whatever, next round button. Minimum and max. Wait, this was also something that I don't need here. Spacing I don't need here. Use motor, gravity, wind. That's everything. And these weird values probably they go away when we find some better ones. I want to keep them from last time because they were funny. No video. Yeah. So this still works. And now for the genetic one, min, max, these were values for setting these things. Spacing are visual things, physics, gravity and wind. Maybe we don't want gravity here. I think it was affecting it in some weird ways. And now the Strandbeest. Maybe should we have the Strandbeest have a parameter for how many left legs and how many right legs should have, and basically just say that each leg is one full Strandbeest and use its update method and everything. I think that is kind of okay. So left leg count by default is 3, and the right leg count by default is 3. Left leg count like this, and here the same thing again. So true at the end for the flipping stuff. This AI did something funny here. Okay, now it works as before. So the idea in this other page with the genetic algorithm is that we just need one leg. So here we could say left leg count 1 and 0 no right leg. And it doesn't work because we are not in the correct page. Okay. Gravity is off, yeah. So I set off the gravity here, but if I put it on, it will collapse like that. Yeah, that's as expected, I think so. I also want the Strandbeest to be fixed, so attached to something. In the particle we had this is static, so maybe we do static support. By default it's false, and when we generate the legs, the new leg, angle false, static support. So now going to leg, the constructor here is flipped static support false by default, and which were the static ones? P1, P0, and P2. And this static support, I also have to set it from the I don't think the object needs to know about that, so maybe we just pass it like this. And given length is flipped rotation static support, so flipped rotation static support, and that means here we don't need this anymore. So refreshing now, it still kills it, but true here. Now it floats in the air. So this is what we need for that simulation. But the other one, this one, it falls down. So it the gravity is affecting, and it's not doesn't have one of those supports. So it's great, backwards compatible stuff. Attached to wall, so to speak. Okay, but I don't want just one Strandbeest. I want many of them. So generate legs for optimization. This was something kind of useful. So spacing, reference leg. Okay. So I will just talk about them not as a single leg, but as the full Strandbeest, maybe. I think it's making things simpler in this way. So the reference Strandbeest will be there, and generate legs for optimization. Maybe generate random. Okay, this is generate random. This should be generate random Strandbeest now. So at this XY location, A becomes, all these values become random. L and M seem to be fixed, so 7.8 and 15. I think we don't want to change the support as well, because then we get like eventually we might get the same Strandbeest but scaled up or scaled down, so I want to keep those fixed to avoid the scaling. I think that was my logic that time. New leg, new Strandbeest really. Origin should be a vector actually, so let's keep that as a vector. And origin, then all of these things. Let's clean up this also somehow. No point to do a duplicated thing. Yeah, so let's just do that. And these are the fixed values. Let's put that marker there as well. And now I don't need this part anymore. And use motor, these are important, so use motor is true. And then really these properties should be the same from the previous one, maybe, I'm not sure. Yeah, actually, let's put here left leg count 1, right leg count 0. So now we can use these like so. And attached to wall, true. And that makes this one like that. And now we don't need the comments because the variable names explain what they are supposed to be. And that's good. I also want to reuse this function at some point, initializing here, let's see, but this seems fine, generate random Strandbeests. And this one, generate legs for optimization, so reference let's call it parent Strandbeest, like relating to genetics somehow. And then this y by the spacing, X by the spacing, origin vector like that. Strandbeest. Push so this is the if there's no parent, but if there is a parent, mutate. Yeah, this mutate, now it's in the leg, but it shouldn't be. We should really have a file that does all this genetic stuff, so we will. But mutate. With the mutation rates. Okay, so this won't be needed anymore. We got rid of that stuff. New Strandbeest. Depending on the length, if it's the first one, then we mutate the parent Strandbeest with the origin vector. I don't know why this mutate needed the origin vector, but and what 0 was. So maybe let's simplify a bit, and then this one parent. 0 was no mutation. Okay, but if no mutation, then okay, that means we just wanted a copy of this object. But I think the mutate with 0 was useful because it was also creating a copy of this object so that it's not a reference. So let's keep it like this and avoid some bugs appearing there. And then new Strandbeest push like that. And generate Strandbeests. Let's just leave it like that. And the mutation, mutate new Strandbeest origin don't think it needs this. It's getting very tiring now. Okay, so with all of this in mind, we have here beasts generate Strandbeests, given the parent Strandbeest and the spacing. And now these Strandbeests are passed here directly, and this draw method goes in here. And now full of errors. Oh. Okay, so probably here somewhere. Okay. Oh, the origin is not stored, but I don't think that the origin is something it needs to remember. So I think in here we just put origin as the global. Actually, yeah, we need the new one. That's why it was there. So mutating with the origin vector also, I can pass it here. And now yes, yes, they all mutate in nothing because the mutation rate is 0 for some reason, I realized when debugging. Or the length is 0. mutates with 0, but it doesn't with this value for some reason. So I'm not sure why. Okay. This rate is, yeah. It's too small. That minimum and maximum is something that could be used, but so here it's 0 for the first one. It's fine. It's just going to copy the parent, but then this way of mutating here should be different. Now it's different. These buttons don't work, but now it's a little bit different. So line 91. Sorry, I can't really, yeah, concentrate well now. But we have some duplicated things here. So this mutate and generate random Strandbeest is really the same thing. If I do a parent is null, let's see if the other one works. So that should be really random everything. So everything is random, and some of them have such a weird configuration that seems like the points can't move, and there is stress happening here. So this works, but I want the generate random Strandbeest to be working similarly to this mutate. So here it's fine to get values between minimum and maximum, just random values. But mutate, what if we say here random Strandbeest to generate random Strandbeest like that, and how about we say lerp from A to the random Strandbeest given value A with the mutation rate. I think this would work because if the mutation rate is small, then the value becomes close to the previous one. Yeah. So let's try to put back the previous one here. Yeah, they are different, so it seems to work. But now generate the random Strandbeest. So this is not used. This parent, yeah. So this parameter is not used anymore. It should do this one like that. It's the same thing, really. So yeah. So we have mutate a given Strandbeest. We have generate Strandbeest. Yeah, I'm getting just very tired. I would like to call here generate Strandbeest, and that one decides to use these parameters. But then if the parameters are not present, it's gonna make random ones. So these are given. We do that, new Strandbeest like that. Generate many of them from this parent. There is a parent there given. So maybe this is called, yeah, it's fine. So these are some given lengths, generate Strandbeests. From this parent, we either generate random ones if the parent is missing, or we mutate them, but we keep keeping the first one unmutated. Yeah, and then we add them here. So generate random one if it's not there. If it is, we generate them with the mutation function. Okay. And the generate random Strandbeest and the mutate Strandbeest, these go, I think, to the genetic file. So yeah, let's move it somewhere here. Genetic.js, and then somewhere here genetic.js, and let's just move them there. to get them away from here. And the random one also is kind of a part of a genetic thing, I guess. And have a completely random mutation there. And then this mutate is there. Okay, okay, okay. And does this still work? Seems to still work. And at the top here, if we don't pass the parent, they are all random. But if we pass the parent, then it depends on this mutation rate. So now they are quite similar to the parent, but maybe a little bit different. I saw some movement there. If the mutation rate would start to be something bigger, like 0.5, then it's very much maybe 0.2. I still want it to be close to the parent, but now it's different. Okay. What does this next round do? I don't know. Generate legs. So I think that we generate Strandbeests again, based on the best ones from previously, so something like that. Yeah. Line 91, typo. Yeah, 91 is already probably a different one, but parent Strandbeest. Yeah, let's see if it's in the genetic file now. Yes, thank you. Thanks, Adrian. Still works. Great. So, almost command. And yeah, I moved it. I realized. Let's check a little bit the comments. So nested loops, yeah. I mean, tracking camera is not something very hard to do, I think. Obstacle course, it's a challenge because now I only have that flat terrain, but not a very big thing. I think this is something you can try. Hi, Osvaldo. Okay, Colombia. Yeah, I don't know about amazing talent. I just like these things very much. And I practiced these things a lot in the past. Yeah, okay, I caught up. Another best. But I think that there are, I don't see it anymore. But anyway, I have to continue now. So scoring. I think we moved the scoring functions in the genetics as well. So at least like can't think about separating the scoring also properly. So what do we have here? I want to scores, leg score. So leg of legs, leg score, max score. Let's say here, and now looping tip point paths. Okay, and here we say tip point path. No, I just want the tip point, but the Strandbeest tip point is going to be something. Get tip. Leg index. Get tips. I think we can go with get leg tips and all of them. And here we say, because it's just one in this case, so this legs. Okay, legs, endpoints, tip. No, tip is something else. P8. Okay. Get bottom points of 0. So something like this. And this tip point path is bottom point paths, but bottom point is kind of bad. It's should be the tip really, but now tip is the tip from the motor, and because if the thing tumbles, then the bottom is the top and whatever. So points that should be touching the ground, the particle. points that should be touching. Get bottom point 0 dot location, I think. So get bottom points. Get endpoints bottom. Okay, so this should be fine. And then here, because we know it's just one leg, we can say that. And bottom point paths, they update like this. Okay. And let's see if the code still works. Okay, it's something. So let's see if we can draw these. I really want to have some statistics here. There are the paths. So this is the original one. And there they are. So they look very good. Very good. And let's look again in this leg, because tip, score paths, okay, this is something that we still need from here to score those paths somewhere. but this will happen in the statistics. So I'm going to remove it from here and paste it somewhere here that we need to do something with it. And the leg is now perfect. I mean, it doesn't have, it does have sticks intersect. These also have to go away somewhere in the statistics, maybe, I don't know. Sticks intersect, probably some math thing. But stick and then intersect another stick. I think this is something that it can stay here. Good, but it's simple otherwise. And the error, okay, this is for the stick there. So I was looking at the leg. Mutate, we don't need this anymore. Mutate goes away. Generate coordinates is Peter's thing. Set endpoints, generate leg, get endpoints, and update. Score path, not necessary here. Okay, everything still works. And the other beast was the Strandbeest. I think it had some... No, not this one. Where is the rest of the annoying code that I was supposed to move to statistics? Lever, no. Motor is good. Particle is good. Physics, maybe. No. Not here. Statistics is coming. Stick. Intersect is there. Intersects another stick. Strandbeest looks good. Yeah. Utils looks good. Vector looks good. So it's good. Let's go to the final thing that needs to be cleaned up. Is the statistics. So scoring the path, we need a function for it. Sticks intersect. There is one here, but this is for everything, I think. And crazy stuff, because some sticks could intersect and blah, blah, blah. Oh boy. Come on. Work your brain. Score path, let's start with this one. So I'm going to take it here and have it as a helper function. Now the scores, score paths, let's score all of them. This scores is something like that. So scores this bottom point paths map each path center of mass, whatever. I think that I wrote in the Discord some idea for how to do this. Peter also pointed out this one, but I don't have power now to read that MATLAB code. So I'm going to try this dividing the path based on the two extremes on X. So the top part and the bottom part. Then the score could be ratio or difference of the top to the bottom area. So the bounds, this is something important. So the bounds come from the path, each point like that. I'm not sure if these are going to be proper really, because it might not start at one of these extremes. Let's do what it's doing here already. So the bounds are like that, center of mass. Okay, y offset, center of mass, path. I don't try, I think, to make a better method, but just make the old code work, and you can experiment with it, or I do it some other time. But this is something with some circles there, I don't remember. I guess some area I was trying to do last time also, and here I was trying to emphasize more the roundness, or yeah, something like that. I wanted the thing to be round, but between 0 and 1 is a perfect circle, y offset, bigger is better. So two things that should be optimized. Okay, so this is like that, and these are now scores. So when drawing the paths, we can first score the path, so they have some score, and then the color here doesn't seem to work. So what are these scores? Undefined, of course. So this scores each path, area, length. Okay, return this here. So now colors appear, but the path is incomplete. And the path now starts to have repeated loops, and these are somehow interfering with it. How do I keep just the first part? So I would like to not, the path is drawing itself again and again and again. So this issue is, this is causing this problem. But the Strandbeest is moving with some kind of speed, right? So we never, the motor has a speed. Okay. So so this would be the step that the yeah. Okay, and here we have that, but this one push, we only push if length greater than less than pi divided by the speed. So we don't add the bottom points anymore unless it's that. And this means it doesn't work. So the speed is pi divided by 10. Pi divided by 10 means 10. No. I still don't like that these are almost the same thing, and I can't think about it now. But now, too fast. And it does just have the path. That's on purpose because I wanted to see that it's going half the path. Otherwise, okay, now for some reason it's not completing it there. I think this is fine. This small gap is okay. We can go here and put this 100, and I think it's gonna close even more. Yeah, it's almost perfectly closed. And now you get this green here. So it's obviously one of the best ones according to our function. The others have different colors, so green is the best. Other colors are not so good. Oof. This is in the statistics now, so okay, update score paths seems to do something. Draw the paths, it's now drawing them with that different color. So why is this color? So if the score is between 0 and 1, what are the scores? Let's see if the previous one still works. It doesn't, of course, something broke. We don't have the speed for the other one. So let's put it like that and modify a little bit the priorities here, because the leg count and this other stuff comes later, and then in the genetic modify also these, so like that, and this works again. Great. Okay, because now this speed is a little bit different than previously. It's behaving a little bit weirdly, but I think it's fine. So if we put here 0.02 like before, I think it wasn't doing this weird reverse movement there. Just a small artifact of the speed. Okay, and these ones, they don't work. Yeah, these other functions also. Of course. Ones I hate, I don't have time to refactor. I think it's one of the only things that I won't have energy to figure out how to unify these into one. It's not hard, but I just had enough. Okay, so now this works and this works. It's good. And back to the statistics. So final thing really, we are drawing the paths and they look now. Why were the scores like that? So statistics scores. I'm getting above 0. I'm getting not a number. Not a number for this one. Okay. It is doing something weird. Intersecting. Maybe, let's see. But the first one is getting 135. Maybe it's I think this will be redone at some point, so it's fine. Have to think how those are calculated. But this scoring of the paths, so these things with the intersecting, so if at some point the thing intersected, it should disqualify them. This is not a number, maybe because it was static or something. I don't know. I don't want to do the intersection stuff because now we do the scoring just based on that tip. So let's try to move this to the Strandbeest as a helper function. So the Strandbeest sticks are its sticks plus the sticks of the leg. So let's just go with all of them. Okay, and then sticks push this sticks, this is fine. And then going through all of them like this, checking for the intersection, found intersection, true, true, and check disqualified. I don't know if this is how you write it anymore. I'm so tired. And I don't even have energy to look what it changed. Okay, so I'm typing. Disqualified. Let's say handle disqualified. Okay. And in the statistics, when we score the paths, when we update, okay, they are getting gray and they are all disqualified, but that's because some of these segments shouldn't be checked. So these segments shouldn't be checked at all. These sticks, 1, 2, I don't know. So L, LAN, M, J, and K. Okay, so A, L, A, and then J, K, L, N, M. Come on, brain, do something. No, except for B, C, D, E, F, G, H, I, and J was in the other group, so. Okay, so doesn't work. These should be disqualified. I think problem is that we don't check this one that should be checked with those that shouldn't be checked. Oh. These need to be checked. These don't really matter. I think these selected sticks should be checked to all sticks. But make sure they're different. So why is this? Why is nothing getting disqualified? Yeah, I think I have to call it a day. This has been way too long. And this disqualified stuff, I just remove it and commit. So it can be solved, but not now. And no. And in the statistics, we still have this measuring of how good the score is, but some of the paths should be disqualified by other reasons. Okay, let's set the mutation here to something smaller. So actually this value 0.1 was fine. And this next round button, so Okay, this one with the scores. It was doing some fancy stuff that if the score is calculated, then the next round. But now we calculate it all the time, and we just have to wait until it's done. And then pressing next round, the last thing is generate legs. What? So in the genetic, generate Strandbeest. Yeah, so scores is statistics scores. Max score is that. Best leg, best Strandbeest is Strandbeest of the score index of the max score, and then generate Strandbeest's spacing and the parent. Looks like similar thing, and like that. And I think that means that we have to make them with the let here. Yeah. So if I'm gonna put this one to 0, and maybe this is the best one, I'm not sure, but it should be a green one anyway. Next round with 0 should mean everything is the same. It's not all of them are the same, but these paths are not being cleared. So statistics need to be also updated to the new Strandbeests. They were using the old ones. So let's try again. Whatever green path here, maybe this or that, whatever the best function scores, should be for all of them. Weird. I mean, it is for all of them, but why do we get different colors here? This kind of makes no sense. They move perfectly in the same way. I think this scoring. Oh, wait a second. The colors for the scoring, they are. So everything I think works as expected now, but the colors for drawing the paths. I don't get it. They are the same. they look the same, but the values are different. So the scores from these bottom paths same number of points. The points will be different because they are offset, but the properties here y offset. What is this y offset? Okay, let's put just the roundness. Now the roundness, the roundest path should have still something weird. Yeah, I'm Okay. The y is the same, and then it changes for all of them, and then the x is the same, and it's not exactly the same. It's close enough. I really don't get it. Oh, okay. Uh, the draw method. Draw method. With the score and score index. What about this this mutate? So what if I just do this? Still the same, still different scores, even though it's really the same thing. And the scores seem to be significantly different, like 0.4, 0.2, but they are the same. Yeah, sorry, I'm scrolling way too quickly. Should really be the same. Zero zero 4, 004, 01, 02. They are different. This is different than this. They are different. They are different because of the different order that the physics is applying the constraints. Yeah, not the constraints, but setting the things differently. Okay, so it's fine. So it's fine. Let's see here when we are approaching this line. So this point is touching it. All seem to be touching it. But everything seems to be green at the moment, so let's now everything looks good. Why does now everything look good? Oh, because the scores are now something weird. Stupid. I'm so tired. I shouldn't do this anymore. But I want to leave this in a decent way, so at the center of mass, but let's just put the actual formula we had previously and try to investigate again. So let's choose. Okay, so obviously they are doing kind of the same things, but I think it's not exactly the same things because of how the physics operates on them. And I'm going to try to prove that if they do look different to some extent, then that explains it. The scoring is fine. Perfect. Why are all these colors appearing there? 3.75, 3.30, 5 point something, 2 point something. Okay, the length is equal. The area, it's not. I think this should be fine. Okay, let me commit. But I think that I'm soon ending. It's um, let's see if this AI wants to re-implement the compute area function some other way. I just hope there was some bug in the previous version. No. Let's leave the previous. I think it was good and it looks like the compute length. So let's see if the bounds are not even used when computing the area. So the length of the area seems fine. So it chooses that one because it's the longest, and then all of them seem to have the same score. So it's great. But the area of the path, how about bounds max x minus min x? These should also be the same. they are the same. Max y minus min y. So it's same. So it's good. But this area calculation, what? And all these other values, like area of circle, I think that this is also going to be the same. It looks just as I expected here. But then this, and then radius of circle, I want to debug these because yeah, everything is fine. So this area is the only thing that different. And it's really the last thing I want to do. a feeling that that final point there is affecting it. The one that we are skipping here. I think that because each path has an offset, this last thing that is missing might be worth differently. Okay, last try, and if not, then that's it. But I'm done after this. So when calculating these statistics, so we add these +1. +2. Why is it not going there properly? Okay, you found something there. Yeah, I think I'm going to take Adrian's fix from there and try that in just a second. I don't know why I have to add thingy here values. My head just doesn't work anymore. But now this is fine, at least almost fine. And now I'm expecting this next round to be, no, it doesn't work. So let's just leave what we had here and let's see what Adrian is talking about. So function compute area. Yeah, this doesn't let me copy it in a nice way, but okay, and then works. I don't know why, and I don't want to look at it now, but thanks a lot. um, yeah, and now with the area fixed, I can update that scoring function to use this, let's say, roundness. So now this should converge to very round shapes. Let's try a while. Okay, now this is causing some problems because of those intersecting segments, but I do see very clearly round shapes coming more and more. So that's just fine, but something weird is happening that it shouldn't. It's forgetting the first one, or what is happening now? Yeah, okay, so it's working. But this roundness was just one component, so the idea was roundness, and then I multiplied it by something. It was supposed to do something with both of them. Okay, so it seems like it does look like that. And now if I change a little bit, yeah, the shape of this path. Okay, but now the problem is that it starts with this very good one. So if we start it with the bad one, like there is no parent Strandbeest past there, it starts with a very random thing. And now let's see what the best one from here is supposed to be. I don't understand why now everything is different. They should really be the same. So now it's kind of fine, but not quite. Okay, maybe all of them become something. Yeah, there is still some kind of weirdness to this everything. Minus infinity. All of them are. Yeah, I think. Ah, the top part. Yeah, it's clipping the top part. Um, clamping the top part. That is fine. It's okay that the top ones behave a little bit strangely. I think everything is fine. So to get variance, we need to do that. Okay, everything is good. Let's do a final commit now, and then playing with these things is still something important. Let's also check one more time that this one works. This was the great one. It works with the wind, that it works with the motor and everything. So yeah, really nice. I removed this one because this piece of these values don't make sense anymore in any way. Yeah. And the one for the genetic, yeah, so that scoring thing in the statistics, it would need to improve. If somebody wants to do more things here, then you can submit on GitHub, and at some point I'm going to check those updates, maybe make another stream on this topic. And then I think that because we have so many things done here, we could really progress very fast in the future. I just need to be somehow fresh, and maybe other people can contribute. I also want to try that gravity that pulls like different angles, or climb up objects, or maybe even try 3D visualization or something. I don't know. Yeah. Okay. Yeah. So that's it for today. Wait, I don't want it to start with the bad one. So maybe optimizing the one that is already given is relatively easier task. And also these colors here. So the scores, I don't like that the scores are being used directly there. So let's try 10. 100. Okay, 316. Maybe it is fine. So green seems to mean, well, no, because now this is the high score. So yeah, and now it starts from yellow. So I think the idea was to start at green and go this way. So green is, I guess, 120, something like that. And yeah, now this looks as expected. Okay, so the genetic thing seems to work. And we also have this crazy movement here, and it works with the motor, and it also works with the wind there. So let's do here. Okay, that's it. Yeah. Ooh. Yeah, I'm gonna go sleep. So that's it. Thank you all for being here and for the help. I couldn't have figured it out without Adrian's help there, and also many other discussions with everyone. So see you, and now let's close this. Actually, let me see if I can give some memberships for free. How do I do that? I think I have to open the stream in this other thing and watch ads apparently. Why are they ads? I specifically put them off. Yeah, so not that, this one. Okay. So I can give 10 memberships this month. So let's try that. Something happens. And yeah. And I guess I can still do it one more time. Maybe. Okay. Yeah, I have no control who gets them. It's just this random thing, unfortunately, but it's something. Okay, now it ends. So, thanks. Hello and bye bye.